All right. Hello, everyone. How are you doing today? You're right. I am late. Yeah. I wasn't sure I was going to do a stream today, but um, I got in one of those places where I was doing like a lot of writing and just thinking in general. The last stream was, quite a stream, I have to admit. Um, that one could have stayed with me for a few days, kind of thinking about it. It's I think if we let it go, this web component conversation would carry on forever. Um, and we got lots of other interesting stuff to talk about from my perspective. Um, I guess the most interesting thing to me, like the kind of couple revelations after the last stream, was there was a comment about um, reporting performance issues to the browser teams, and I was like, kind of like it seemed reasonable, so that one would be more expensive than the other. So I was like, I don't know, I just didn't really think of like bugging them about that. And I thought of actually a good comparison in my mind. Can you picture? And I mean, I don't know if this happens, but do people go to like the React GitHub and then like report performance issues and are like, I made this little thing here. It's slower in React than it is in Svelte. Um, so that's a bug. Do people do that? Like go on Angular and be like, you know, this thing done in Solid is faster. It's a bug, right? It's interesting. I think performance as a source of bugs is one of those things that is tricky, right? I love when people report performance bugs to me because then I have a chance to fix them. I'm not aware of them. But I think a lot of times people actually doing the reporting are kind of like, is this a bug? Am I just doing something that's slow? It's sort of like if there is no erroneous behavior, unless it's something that gets to like considerable extreme, most people will assume that performance is the baseline, not a bug, so to speak. It's just an interesting observation. Mm. How are we doing so far? People, people joining in here. Um, yeah. Sorry, just getting a little couple things ready. I was working on Solid Start release and router release today, pretty much right up to the wire. I did a release like 5 minutes before I started the stream. You have to have a very deep knowledge of the framework to know if you should report slow performance. Yeah, it's tricky, and to be fair, that level of depth, um, I don't even think framework authors necessarily have on the browser side. I would say like people who implement the browser have that level of performance knowledge. For of versus for let should be reported. Yeah, yeah, yeah. Anyways, people come say hi in the chat. Sorry, I was a little bit slow getting rolling today. Hi. Hey. Performance must be not just the worse than others, but atrocious. Otherwise, well, whatever. Exactly. Ask AI. Yeah, it was just something I was thinking about because like I was kind of put on the spot there, and it was true. I was like, they're like, why don't you report these things? And it's like, if if something does more or less, you kind of like do some amount of discretion on the platform. And everyone knows when you're being as like crazy about performance, in benchmarks as we sometimes get to when we're working on these tools, that something can be, 20, 30% slower when you do it like a billion times in a row, in the hot path. And like, it's okay. I mean, I'm sure people would want to know to improve it potentially, but then it's also like, it's not really a bug. Like, yeah. I'm glad I'm streaming too. Do you have a link to that? How much performance size difference are just the drop in support? Other than the North support, hardly anyone uses. To be fair, the size aspect, I would say, is not huge. It's shared zones. Things like spreads, you know, things like dynamic elements. There's a bunch in the compiler, but I don't care about the compiler. You know what I mean? Like, I think that's why you use the compiler. If the compiler is more complicated, if the compiler has more cases in it, like, so be it. You do it so that you don't have to ship that code. Where else would this be? Event delegation. I mean, I like that just like disappears. But that's not, again, like what are we talking about? You know, actual runtime code size is probably only maybe 300, 400 bytes, like maybe half a kilobyte. Well, I think it's a little less than that, right? I mean, for libraries that are trying to ship 4 kilobyte bundles, half a kilobyte is a lot, but in the grand scheme of things, it's not much. You've been out of the loop? What's going on Solid lately? SolidHack. That's probably been the biggest thing that's been going on. I've been working away on a lot of prototypes, a lot of stabilizing solid start and whatnot. But the hackathon actually is probably, let me just see if I can pull this up right now. Hack solidjs.com, and let me share my screen. As you can see here, there's still almost 27 days to get your submissions in. So there's 20,000 in prizes. The main prizes are 15,000, switched between the categories and challenges here. See, like or I guess it's 12,000 for the main prizes, and then we have a whole bunch of these challenges that we do like on a weekly basis for, you know, whoever fills them in. We just add more of them in. So the bounties are like 500 to 1,000. We've had a few winners already. We're using this as not only a way to award excellence, but also, admittedly, as a way to help us fill some of those missing pieces. If there's something actually you're interested, I think we might be a little bit tight on time. We might be doing one more drop on Monday. I don't know if I need to double check with David, but if there's anything missing in the Solid ecosystem that you kind of want, this is a kind of nifty way to put a bounty on something. I feel like the only way web components could be better performed is if they allowed you to ship less JS, and I'm pretty sure they don't. Yeah, this is the other thing, right? I realized that on one side the performance thing, but the other thing I stepped away with, I'm not sure if people realize that web components like don't do anything. Like from like a framework standpoint, there are things they do, but like when someone says, "Oh, I moved my app from React to web components," they're not saying anything. They're saying, "I moved my app from React to something that I'm wrapping up in an extra container that doesn't really do anything." Do you know what I mean? Like, it doesn't explain the architecture. It doesn't explain like how the authoring is, how change progression works. It doesn't really explain anything. So a lot of times when there's like that argument and people are like, "Oh, Microsoft did this," and it's like, and they got, you know, X improvement, it's like, okay, the good starting point for a conversation, but what did they actually do? Web components are like a wrapper, you know what I mean? Like, go and make a solid component, make it a web component by putting a solid element. It's just, you know, it's just an extra layer. So like, it basically in itself does absolutely nothing to reduce JavaScript or do anything. It's just like a container. So I seeing these conversations, I think people don't get that. Like, and that's part of that conflict, because when people are like, "Oh, I switched to web components. They are doing that same comparative framework or framework component thing that they're like, don't do that. Like it's because like, what does that even mean? What the answer is, we switched to our in-house, library, or we switched to using lit or something. That's all it means. It's like, and is lit faster than React in a lot of cases? Yeah, So, it just means they've changed their framework and added some extra wrapper for interop because they thought that was important. But that wrapper itself has no impact on things. Hey, let me pull this up on Twitch. I'm going to get Twitch going in my other window so I can see what's going on, see any of those subs come in, Yeah, let me see here. What do you got here for me? I'm excited for we finally getting custom select on the web. However, it's one day I'm not sure. I'd like to hear your thoughts. But there's some clone node conversation here. It means that it's a copy for tree and clean out, but not. Oh, this is talking about the fact that clone node doesn't actually copy anything, only like the actual attributes. Yeah, I remember this when I was working on web components. Like you get the attribute, like all the like random JS properties you add to an element when you clone it aren't there. Event listeners, yeah. I mean, it's kind of fine because that's how everything else works. But yeah, the DOM is a funny and tricky place to be in general. Yeah. If the broadcasters run them for hours, then I'd be able to watch them in translation in my native language thanks to capability of Yandex browser. Interesting. Yeah, I didn't realize that time impacted that. I'm see what I can do, but I don't know. Oh, nice. I was successful. Solid one has been solid all weeks. Big fan of this prefetched on link hover. Yeah, and we made a big improvement to link hovering just the other day. We noticed on iOS that only iOS, of course, everything's a little different. That that basically it was like slowing down navigation by like hundreds of milliseconds, and apparently on iOS, on I don't even think it matters which browser you use, but let's say Safari, if you go to click on a link and it has a mouse over on that element, it basically like runs some sort of animation or does some sort of thing and actually delays the click. Like you click it and then it's like takes 200 seconds or milliseconds for the route to change. So we looked at SvelteKit, got the answer there, and they use a mouse move event that they cover the whole screen to do it. I had to change my my approach so it fires more than it needs to. I did a little bit of optimization there, but it's actually less code and it's faster. So yeah, if you get the version 0.149 or 10, it's the latest I've released today, you'll have even better preload characteristics. Oh, hey, Aiden, how's it going? Yeah, it doesn't matter compared to the app code, right? This is the thing. If you write a React app and then even come back 5 years later and write the React app again, like you've learned some things. Hopefully you do better. It depends on the situation. Sometimes that can get slower because you pull in new requirements and things change and it's a mess. But generally speaking, I've heard a lot of success cases where people are like, look, I took my React app and migrated to Solid. Look how much faster it is. And I'm like, how much of that is because you just rewrote it again? Did anyone claim the UI? I mean, I don't think so. There's only been 2 prizes claimed so far. Dax. I want better solid element. Better web components. Let's do it. I'm interested to hear more about this. People keep on telling me we do have good options like Corvu and Cobalt. Yeah, you know, and I know Arc supports us, and I don't know enough about like boneless versus headless, skinless, whatever they're doing these days in this. But I feel like we have a lot of blankless things you can do with Solid. Yeah, so we're done with the web components. You put the foot down, Benton. Yeah, but only on certain cases. Yeah, it was a pain. One solid 2.0. Now, not yet. It's my problem. I start working on ideas and I start progressing, and then I got to go fix bugs, and I get in this loop where there's only this short period of time that I get into implementing on 2.0. I need to break the cycle. There's just so much to maintain, and at the same time, there's so much to think about. So it's tricky. Yeah, there was an article Theo did on a stream the other day, and I learned more about what people were talking about in UI libraries there than I had in like 5 years. I had no clue what anyone was talking about. One solid 3.0. Oh, now you guys are just shooting shots back. Okay. Hey Dev, how's it going? Yeah, I mean the TC39 thing's interesting. Maybe I'll talk about it a bit later. I'm still it's a lot to process because in one reality, it is kind of like how things already are. But on the other hand, formalizing is a whole other different thing. React is already 19. Is there plans for Solid to work harder to get to version 19 as well? Not currently, but Angular, I think, had this in the plans. Angular 19 also just came out. They managed to catch up. And I mean, that's impressive because if you think about it, sure, they got a head start, but React jumped like 10 versions or 13 versions, right? They went from basically like 0.13, which was like the first version, all the way to like 0.14 to 15. So they like 1, 2, 3. They jumped 12 versions basically. So Angular is already caught up to 19. So yeah, Solid should go to from 1.9 to 20. Yeah, that's the solution, isn't it? Uh, there we go. Yeah, 1.9 to 20, just like React. Thoughts on TanStack Start? TanStack Start's great. Tenor's building on the same bones that we're working on. He's gone much deeper down certain things I think matter a lot for the developer. To be fair, he's kind of has to go there. See, this has been kind of my concern here in general. It's like because of React, there's only so much he can do. So he has to come up with ever more interesting solutions to kind of get around the fundamentals that he needs to get from React. Whereas with me right now, I'm approaching this kind of from the basis and being like, okay, what if we didn't have React? What if we were just starting from scratch again? What would it look like? Which frees me up a lot from a more theoretical space. But what's great is me and Tanner align on stuff a lot. And I shared with him some thoughts, which actually led to me making the stream today. And he's like, I'm in complete agreement. So I was like, okay, that's all I need. I'm going to talk about it today. Yeah, very awesome. Heard it's fine. It's like TypeScript, right? TypeScript goes from 1.9 to 2.0. So you just combine TypeScript mentality with React's upgrade, back from 0.14 or whatever. Was it 0.15? No, they had actual 15. And that's the answer, solid 20. We'll just skip past all the rest. Yeah. that's progressing around. We'll have Tanner come back. We'll show him what he's been working on, because he's in an interesting boat, as I said, because he's trying to like build even more considerable, more like constructs on top of the stuff, which is really valuable. I mean, I in a sense, even after this too, everyone's trying to get like validation on their server functions, all this extra functionality, and that's great. Someone can do that. That's someone that's just not generally going to be me, because I know that someone can do it, which means it's not an interesting problem. I'm interested in the problem of things they can't do. But I think he's really taking it a good distance, and which means it's a good time to probably talk about it again. Yeah, I mean, the key to it would, yeah, I mean, just TypeScript can't work the way TypeScript works if we wanted this to work. We'd have to have some way. I mean, people are talking about syntax or signals in the browser that didn't involve function calling, so that we could like fool it essentially for TypeScript perspective. It's interesting. It's just also like there's a lot of implications of that kind of change. And the second you need it to be transportable, you're in functions again, and you're in the same problem again. So it's not as simple as that. And using stuff like property access, like dot value, as we know, is a trap. So it's like there is no great solution unless TypeScript itself changed. And who wants to bet TypeScript itself is going to change? It's basically tRPC into the framework, which is fine. Which is good. Like I don't have seen OrJDev's work. We have pRPC, which is a compiled thing. Him and Tanner probably should share notes. It's very similar approach, right? Which is pretty cool. You know, I think it's cool at least. This idea, like server functions unload a whole bunch of potential to build on. Yeah, I mean, tRPC is fine. It's just getting absorbed is essentially the reality of things. People, yeah, I mean, if we go monolithic, people don't want to go through all the wrappers anymore. Yeah, I think that's what should happen. I think where my mindset is, OrJ should look at what Tanner's been doing and just kind of find a good zone around there, because that feels like where that belongs. It's the next level above where I'm generally working. Okay, so yeah, we're just talking crap, but let's actually get into something. We want to talk. I want to talk today because, as usual, I've been writing hack MDs, but let's actually start with Excalidraw, and just start a brainstorm session for a sec. Okay. I know. And later in the stream is the most you part of the stream, because I'm going to be talking probably about some of my hack MDs that directly reference your work. I'm sorry, Tommy, but you know what? We got a solution for that too. You can be a guest on the stream. You've been doing some great work, and I want, if you think you're in a good place to showcase it, you should come and join me. All right. Soon. Okay, that's awesome. Yeah, I know it's a very R&D kind of zone. Okay, so let's get into the topic today, because I want to throw it out there. I don't actually think there's that many different ways to build web apps. I mean, if you remember, like from a high level perspective, you remember a long time ago, I wrote this Patterns for Building JavaScript Websites in 2022, one of my most popular articles, and I said, like, I was responding to an Adi Osmani chart that he had, where he showed this table, and all the framework authors all argued about what features they supported and all this stuff. And I was like, okay, no, I break it down to 3 questions, right? Navigation, and I made this matrix full of like different things. And we talk about this, like every time I do that like yearly recap of where JS frameworks are, you know, for New Year's, we talk about this, right? We look at, you know, how rendering works, different types of rendering, timing, SSR, streaming, SSG, We talk about hydration. And all these characteristics sort of define the solution. And if you take the combinatorics, there's like 60 different combinations, or 120, I think, combinations. And of those, maybe only 60 of them are viable. But it's a mess when you're like, what the hell is going on here? Right? And it's like, let's step back. You guys know that I've been looking at server components. You know that I've been looking at, different architectures. And I was like, I actually think there's 3 buckets only. SPA, or if I say SPA, everyone knows what I'm talking about, right? What else do we want? Server components. And what else do we have? What's the last one I'm gonna say? Stateful servers. I think I can bucket all rendering on the web into these 3 categories. Let's make this 2 lines, it's too long. For applications. Sorry, I wanted to. Don't get me wrong, there's also MPAs still, but I don't consider MPAs necessarily application level. I think there's really 3 architectures we're talking about. I need to look more at Brisa. Yes, I'm gonna talk a bit about that later on in the day, about the resumability stuff. Right, but client-only SPA, SSR SPA, yeah. No, but I'm going to consider those the same category, right? High level, I think there's only 3 categories, right? Like over here, we have like what's defining of a single page app. Clients. I mean, I think all of these have client routing, but big thing is state owned in browser, right? Stateless server generally. This is not a rule, right? But I'm just like, characteristically, single page app, what are the characteristics about this? More important. Client rendered, like when you update, right? Whether you do SSR or not, it's a toggle, it's a switch. It doesn't change fundamentally that it's a single page app. Yeah, where do islands go? I think islands are over here somewhere in server component land here. Because like what's over here, right? It's interactive parts. So like client components, islands, whatever you want to call them. What other characteristics do these have? Also stateless server generally. It doesn't have to be like, you can always have like a web socket connection, but I'm just like, the baseline is stateless server, right? It's it's RESTful. It's possible to have client routing, but generally, like server components, I'm going to say, it's not about the routing, because this is what the problem I put client routing, because they all have client routing. It's more of like server rendered navigation, right? Maybe this is the better way to put it, because I'm going to say, I'm talking apps here, so I'm talking client routing generally. Client rendered navigation, server rendered navigation. Like the difference between islands and server components, there are functional things that you need to consider when you're doing server components versus islands, but there's the same things you have to consider when you add view page transitions to Astro. So to me, this update on the MPA is fundamentally boxed under this thing. You can, right? SPA is in remix SPA mode. Now you're just poking fun at them. They should have called it like CSR mode or something. Like in Solid, we call it SSR false. Remix, all modes arguably are here. Even with their server components, architecturally, they are still over here. TanStack is here. SvelteKit is over here. Because architecturally in Remix, when you put the server components as the data loaders, you're still running in a client-driven thing. Don't get me wrong. Server components are this weird hybrid that you can kind of like do server components without a server. But architecturally speaking, the whole benefit is when the server is on the outside, right? Because then you only have the little pieces. Remix does it backwards, which means it's over here. Like when people make lakes, like server components, they load, you know, like the kind of reverse Nux idea of server components. They are still over here. They're all at an architectural level. React server components are over here. What Next is doing, almost what everyone else is doing is over here. No MPA is allowed in the stream. I mean, it's just a server components architecture with the routing turned off. Thank you for the reminder. Yeah, like and subscribe. It helps me so much. Seriously. Serverless. I mean, most of these run on serverless because they're, but I think you mean like React server components without a server. Or maybe you're talking about offline first. Well, yeah, I mean, that's another question. Where do you think offline first fits? Generally speaking, offline first is over here too. Well, you know, offline first, lakes. Like these are just other things that are actually over here, generally speaking. I mean, it doesn't matter if they're SR or not. Categorically, there's this bucket and this bucket. The funny thing is people didn't realize that this was a bucket before for apps. Like, to be fair, they were just like MPAs, which I didn't put on the list here, but yeah. Yeah, Dev, you beat me to him. The islands themselves are the client components, but the architecture is what I'm talking about. That's why the fact that there are server components doesn't beget necessarily like the categorization. It's the fact that like that's the architecture of the app. Like you build an app that renders everything on the server with client islands on it. Zones of specific interactivity. Okay. Well, the thing is, you can argue that because of the ability to preserve state, but now that there's stuff like view transitions and stuff, you are on the ledge. And yes, you could argue that view transitions are just letting MPAs not do full page reloads. And if you forget about state persistence and sharing that model, you can get pretty far. But you're also probably not building apps. You're probably just building sites now that have slightly better navigation. You're not building things that have persisted state, which is an important aspect here, because it kind of goes without saying that when you have stateless servers, that state is owned in the browser. This is where the similarity comes in, because you might be like, oh, but islands. Well, the thing is, islands just don't bother with the state. They throw it away. It's like if you just don't do client routing, you don't keep the same in the server, like MPA style, then like it's not that the state isn't in the browser. You know what I mean? It's just that you chose to throw it away. Like, yeah, you want to talk about HTMX and like KDOS stuff? Interestingly, HTMX is a technology, not an architecture from my perspective. So for me, when I look at HTMX, just let's put in our brainstorm, it can actually it can either live in this world or in this world, depending on how you build it. We haven't expanded out this world, but HTMX as a technology works both with this architecture and with this architecture. Like on a base level, HTMX might actually be under this category because, again, you can always shrink the islands to 0. You can always straight the state to 0, but at base, it's a stateless server, right? With server rendered navigation, right? Like you're just kind of like with Astro's ViewTrans, you're just swapping in HTML partials, right? This is HTML partials is going to be a word that we use over here, right? It doesn't have to be HTML, it can also be JSX partials, but it's essentially, when I'm looking at this from 10,000 feet, there's that, like, don't agree with the labels, but like, yeah, let's do some stuff. Remix, all modes, spell kit, Nuxt, solid start. So I'm being a little bit aggressive here on the bulk thing because, like, as I said, we could go into all 120 different variations here, but like essentially they for the important characteristics, they bucket this way. Islands don't handle it, but the fact that they don't handle it, like don't handle this, is kind of like a choice. If you want that architecture to work, you need to handle it, right? So it's like resumability. Resumability is, again, a technology, not an architecture from my perspective. So resumability and hydration are going to be basically anywhere that you care about the state being owned by the browser, because the state never, like, nothing starts in the browser, everything starts from the server. So it hovers these lines. These islands can be resumable or hydrated. The single page app could be resume hydrate. So they share uses of this technology, but in itself, like, if you're more interested where things sit, quick is over here. Okay, there we go. Like, we could say that right, let me zoom one more and maybe make it a little bit easier to see for people, right? Yeah, basically. I mean, they're technically the server components, yeah. There's a huge similarity there. Yeah, 100% in the spot range, I agree. Like 6 minutes behind chat. Stateful server columns scares you. Yeah, maybe for good reason. It scares me sometimes too. It's this big blank we have here, but we'll get there. I was thinking about this all day. I was like trying to come up with the things. If you can think of the axes, let me know. Yeah, where state lives, but then what's the other axes? Where it's like, whenever you see 3 things, you always think there should be a 4th thing, and you're like, the 4th thing is the missing part. Like, that's how I found SolidJS. I realized that there was a 2 axes graph, and nobody was in the 4th quadrant, and that's what Solid was. That's how I knew for myself that Solid was worth pursuing more than anything, because I found a unique spot. It wasn't about API. It wasn't about these surface layer stuff. I think I talked about this way back. Let me look at my Medium article. If you just so you get what I'm talking about when we're talking about these 2 axes graphs, way back. React hooks the most performant. I benchmarked hooks here. What every JavaScript framework could learn from React. these titles are wrong. We came up with better names for them, but essentially I'd realized that almost every framework was in Q box 1, except for like some reactive stuff like Knockout back in the day. But React was over here in this kind of forward graph. Don't worry about this coarse grained, fine grained, strict, loose data flow. Those titles aren't quite the right ones. But I'm trying to remember what I figured out what the perfect axes were like on a stream about a year ago. But my point was I realized that nothing was over here essentially, right? And when React came out, everyone was like, the people who are over here, they saw React over here and they all went like this way. But what I was saying is over time, React has slowly been going this way, like more fine grained, right? People they learned the wrong things from React and they all like started, they basically went backwards. So when I created Solid, I started over here and I was heading very quickly into this quadrant. I feel like it would be interesting if the same sort of mentality existed in this space. Anyway. Yeah. Because they're talking about HTMX. I built. Okay. So what do we got here? State view. Yeah. I mean, let's see what that looks like. Sure. I'll bite. So we're talking one axis here is going to be state. Can I highlight this line and put arrows on both sides? Not layers. I want to highlight this line. Can I change the style? Is it too late? Oh yeah, it is too late. Anyways, whatever. State on this line. View on this line. And then I'm gathering. Let's do server. If I've got the idea here, server. Client. So we get our stateful servers here. We get state this server, and then if this is state client state but server view, we get server components here, and then client state client view. Pause there. What does that leave us with? Client view. Yeah, client view server state. There's arguably, maybe there's some space to get here, but this is like SPA plus WebSocket, right? Maybe there's something here though. This isn't the worst. Yeah, you can't have a SPA without an API, no. But the persistence of the statefulness, what I mean is like this where the session lives, you can definitely have a client with sessionless backend. Yeah. I'm just this is not a bad stab at this chart. I don't know if it gives us any any insights just yet, but I'll take it. Okay, let's finish filling out this table. Stateful servers. What do we got here? Characteristics. So state is owned on server. What else? What else is characteristic of this? Server rendered navigation. Other characteristics of this. I mean, there can be HTML partials, but I mean, that sort of goes along with this, right? Like categorically, these are the same statement, and categorically, like these are like, I could say, stateful servers. This is like necessary, right? This doesn't work without stateful servers. You need like some kind of like persistent backend here. And yeah, I mean, for people who don't know what I'm talking about, this is live view, essentially. Yeah, I might as well finish this out. Next, RSCs, Astro, Fresh, HTMX can kind of like hover a line over here. Blazor has some interesting modes that does all of this, but I don't know what it's called in Blazor, but I know that Blazor has something over here too. I mean, when I'm talking about state, I'm talking about stuff that ultimately isn't persisted. Like, obviously people have backends with databases, but when and in a sense, you can access that database from any of the clients. So then there's like persisted state in a sense, but I don't mean that. I mean, like, if you are like the state of the application, not the state of your data, like the state of your UI is what I'm getting at. Who owns the state of the UI? Who makes that decision? Who knows which checkboxes are ticked, right? Generally speaking, in live view, the server knows that. In these other architectures, it's the client that knows that. In the SPA, it's obvious because the whole thing is in the client. In the server components, it's more like the stuff outside of those islands, you shouldn't be clicking anyways, right? So to speak. Marco not mentioned. Marco's over here, sorry. Marco's here. Right? This distinction here might end up not being actually that big, but right now it has a lot of impact. This distinction has existed like between these two and this one since the dawn of the web, essentially. And it's like it's where the line's drawn. Because people operating on the side operate off the assumption that while stateless servers are possible, they're not a guarantee that you cannot ensure that, serverless, whatever. You can't guarantee that, and this has a history probably tied to infrastructure scaling, cost considerations. Everyone on this side refused to make assumptions about the statefulness of the server. They're like, we can't do that. Whereas like with stateful server type architectures like we're talking about here, it's literally like you have it or the architecture just does not work. It's just not there. MPAs? No. MPAs, generally speaking, are not an application architecture. Like you can view them as server components crippled essentially, but they don't necessarily have stateful servers. MPAs are kind of in the middle here. They're like server components where you chose to not use a bunch of the features. That's kind of conceptually, right? When you start with an MPA and you move outward, you end up with all of these characteristics as you try and get more interactive on the client, as you try and scale up from it. So yeah, MPAs are, I'm going to say traditionally MPA. All right. Like a simple MPA is just this architecture and choosing not to use the features in it. I don't think there's any like it's funny because a simple MPA could literally be like any of these because they just don't use the features. Like it's just a website. It's just like here's some HTML. That can be islands architecture. That can be a page with a giant spa on it. That can be the starting point of a stateful server. Like MPAs are just the web. Mentality wise, it's closer to this middle category where you have this idea that you're just like swapping a page, right? But yeah. Baseline, yeah. JSX is a templating language. It's no more, no less. It's the same as felt files or lit tag template literals. It's just a different form of templating language. So it has nothing to do with like, do you want to write declarative code or do you want to manually do your updates or whatnot? I mean, it's a question. I'm strictly talking about web applications in general. I'm assuming, but like I think this can trace back even further, right? Like you can argue that if you start here, you can grow to here, which is like what classically happened, right? But now in like a modern setting, if you like reset and look at what we have out there, everything kind of fits into this thing. Like, who else did I not put on here? Turbo, freaking Rails, Turbo Rails, is here. I like they might have technology on the stateful server side. Maybe that's how you author it. But like, what I'm getting at is like, you can basically like I think certain frameworks can target multiple of these architectures per se, but this is not just how to say all apps that do anything non-trivial require JavaScript. So when you consider the whole puzzle of pieces, I think there's only 3 buckets like that we at least that we've talked about so far. Is it about their soul or state lives in apps? That is who's left holding the state was my old joke of like hot potato about how web architecture evolved. That is one of the like where the UI state is one of the most fundamental questions, and the secondary concern there is who's responsible for actually rendering or like making the decision of what gets rendered. Those 2 pieces together are very key to understanding the difference between like high level architectures here. cool that MPA is not certain fundamental distinction. Now it's more of a choice limitation. Well, this is going with the Rich Harris take, right? When he told the Astro guys that client-side routing was the future, and if they weren't in it, they, and then when they released the view page stuff, he was like, look, even you guys agree, right? While I think there's lots of use cases where you don't need that extra consideration that comes around client-side routing, navigation, there are trade-offs, JavaScript considerations, all that kind of stuff. Fundamentally, from a mental model stuff, I do think it's a natural evolution, right? That's why Astro lands there. That's why Turbo comes out for Rails. Like it's natural that the thing, like my headings can be wrong here, but bucket-wise, I think there are 3 ways we view how this stuff comes together. I have no clue. Like the thing is, when you have a language like JavaScript, you can literally put it in any of these buckets, right? There's live Vue.js. So certain tools, certain languages, certain levels are going to show up in multiple of these architectures, but high level, I think there's these 3 buckets. People are very stingy today on the likes. Is this true? Am I going to have to go on YouTube and bully people and see what they're doing? Let me see what's going on YouTube. View channel. Is everyone just watching on Twitter? Yeah, only 50. But there's 149 people watching on YouTube right now, apparently. So 50 thumbs up, 149 of you watching. That's only 1 in 3. That's not particularly good. How are we doing on Twitch? How many people are in chat? I mean, I guess I can't make the same metrics here. 55 people in chat, or 55 people watching. I guess I can't see the sub thing. That's different. That costs money. Okay, fine. But we can definitely get some more likes on YouTube. Okay, I see 78 now. Yeah, okay. That was good. That's good. We're like 50%. I appreciate that. Okay. It's stateful a superset of MPA? Not necessarily. I think actually stateful, like MPA, like everything extends from that base of what the fundamentals of the web are, that you just are sending back, if you think of the classic file server, you're just sending back files that are in a folder, right? Everything extends from that standpoint. So everything's a superset of MPAs, maybe? I don't know. The one that keeps closest to the original mentality is definitely the middle category, but yeah, HTTP versus WebSocket. Well, I mean, you can also do long polling with HTTP. The part that makes it different is to have WebSockets, you need a persistent connection, which means you need a stateful server, right? I didn't put it in here, but when we want to talk about technologies over here, yeah, I'm talking, this is WebSocket land over here, right? I mean, technically you can do long polling, but even with long polling, you still have a connection with a server, right? 2 out of 3 people are still mad about web components. Oh man. These are interesting observations, right? One thing I never see people talk about is using ServiceWorks to turn MPA to a single page app. Can you work offline? And what if, let's take things further. What if you took a stateful server architecture and put that in the service worker, right? It's kind of an interesting thing, right? Because is that the ideal way to do offline first, right? You can't. There's an interesting thing about where the stuff sits, right? Because when the single page app, almost all the logic's on the web is a client server model, right? There's 2 sides. There's always 2 sides. What putting it in a service worker does is put both sides potentially on the same side, like in the same area. But there's always 2 sides. And single page app mentality has the client doing all the heavy work. Stateful servers have the server doing all the heavy work. And server components, or this thing is this hybrid where it's like each of you guys do what you want, but like it has a harder time choosing sides. I think ultimately because of this tension, right? Like there's this tension here, right? Like if I grab this and I put arrowheads on, can I put arrowheads on both sides? One side. No, I want. Why am I not? Oh, right. I can do it like that. Okay, sorry. If I might have drawn this before, but if you have this line here, the thing is, what do we got here? Client, server. But I mean, the whole thing is this is just another way of saying like closer to the user. And closer to your data, right? Along this line, different operations are more optimal to happen, right? Some things fit better over here, right? Like, let's move this up over here. You know, arguably, ephemeral UI state is better somewhere over here. You know, optimistic updates, selection state, because you're close to the user, you can interact with them. You don't need it here, arguably, right? It's not persistent. Arguably, you know, things processing data better over here somewhere. So like there is this spectrum here, and there are kind of like interesting compromises where the stuff sits, which means that sometimes with stuff like, you know, like a server component type mentality, you would basically choose where the stuff goes. The challenge is then you often have two different models for things. And the other challenge is that like ultimately state does have to persist somewhere. Like if you're building an actual app, there is a place where you probably, you're not going to always fetch stuff. You need some kind of persistent. And for that reason, these generally do that persistence. Like it could go arguably either way, but like when I'm talking about server components, I guess I'm talking about the choice to make that persistence happen in the client. It is possible that you could do very basic statefulness on the server, but like when you get to the point that you're kind of trying to like manage things with client-side routing, you know, like even view page transitions, can take that further, you're going to probably end up in that zone. So there's an argument that this middle section can be split, maybe. All right. Page could be fetched and set as page node without a page route. Yes, and that's exactly what I'm calling under the server component side, right? I mean, give me an example of stuff outside. Like, here's the problem. There's a million ways to nitpick on categorization. As I said, I've gone down this path. I'm quite familiar. We can talk about like you can stream, you can do this, you can do this, but when it all comes down to it in the end, there's the most defining traits, I believe, actually fall into these three buckets. Do you enter the Redis server in backend language, call the WASM, and then load as a service worker and seamlessly transition to local first spot-like rendering? Yeah, I mean, it's an interesting one, right? But the only benefit here is you said to go local first if your database is there. And then at a certain point, you're kind of going, what's the difference between a model where you like, I think one of the things that ends up detracting from this a little bit is if you're already moving to the browser, like both this single page app model and stateful server model try really hard to optimize for their side to the point that you have a single app experience, right? I was talking about this before a moment ago, but it's what's key here, right? Because there's like a single app experience, and then I mean from a DX standpoint, not signal. God, I do that all the time. Single, and I realize this is single app DX perspective, right? And generally speaking, these guys are as well. Where this is like split, is like a split. Like React did a good job trying to keep it all in JSX or whatever, but there is a definitive boundary, and I don't just mean like saying certain things only run on the server client. I mean like even like what its role is when you think about mutations and actions and you think about how these pieces play with each other. It's not just like, oh, this part runs on the server, this part runs on the client. Like it's more than that. There's implications of those decisions. Right. So what I was trying to get at with Ben, with your comment is you could bring the server on the client in a sense, but it'd be interesting. Like clients are already better at rendering in the client. Like the pattern is more efficient. It's more flexible. It's more, so it's like, it's that's what makes it a harder sell. That's why I don't think you've seen people kind of go wholesale on this. It is interesting, the idea that you could take a back end and then just like do the initial work there and then like update and push it up, right? Like, but on the other hand, you could also have that back end mentally like a single page app, like, but and just have the single model. So they're both approaches, right? In a sense, a single page app almost acts like there isn't a client server relationship. And in a sense, stateful servers are a bit like that too. Yeah. Yeah, yeah, yeah. The extremes share more of a common ground in the middle. Yeah. Multi-app pages. There you go. So, yeah, that's probably a better mentality on it in general. Like if you go that approach, then you're kind of multi-app pages. Actually, wait a second. No, that's multi-page apps are an app that spreads over multiple pages. Multi-app pages would be a page with multiple apps on it. That's a whole other can of worms. Yeah, micro front ends. Yeah, yeah, yeah. Multiple single page apps. Yeah. From my perspective, it get that if they're connected in some sort of way, then they're a singular app, even if they're like authored differently. And if they're not connected in a different way, then then they're trivial enough that I think they fall in the middle category. Yes. But the play on words is definitely appreciated and definitely fun. Okay. But I want to talk about this closer, farther thing a little bit here because what are the actions that you perform on a page, like when you're kind of, like how do we even decide between these architectures? Obviously there's technology infrastructure constraints, right? There's a reason that not everyone can use stateful servers, right? Not everyone has access to those, you know, that could be just off the table before you even start. But even between these, you know, there's interesting blurring in terms of trying to figure out what solutions or what style of solutions actually work the best for your situation, right? So, you know, it got me thinking of like, what do you actually do on a web page, right? Like when you're do in a web app categorically, right? Well, first thing you do is you load a page, right? That's something you do. You load a page. You navigate to a different page. I usually press command on a web page because that still falls under load a page. Right? Navigate to a different page. What else do we do? We do some client only interaction, maybe like selection state. And then we probably do some kind of mutation, some way of like some kind of server update. I'm just trying to think, like, does this, like, what other things do we do high level categorically? Like optimistic updates is part of that client only interaction, right? Commit changes is number 4. Yeah, we should add a caveat down here that we should think about return visits / second time it occurs, right? Sometimes you go to a page and come back to a page, right? Sometimes yeah, exactly. I agree. I mean, I get if you have a website, I could see this argument. But at some point, if you're doing an application, guess what? I like this post. There. The optimistic update, I just did 2 of these things just now. I did a client-only interaction, which involved the optimistic update, and then I did a mutation, which did the server update. Persistent state is how we solve a problem, right? This is how we describe the problem. I'm just thinking more of like, I'm gonna pull this out of here. It's gonna get its own thing. Let's blow this up a little bit. Okay. I want to make sure that I'm not missing any kind of like from a user perspective, what kind of action that we're doing. Get server state without interaction. Interesting. Okay. I'm going to put this one in. I think you're right. Because this is like client sourced events, server sourced events. This is not what you do, to be fair, but I think we should consider it maybe. At least this is something outside of the box. I'm not sure where this sits, right? Because you could also like background processes that pull for data. Like you can set those up in all of these solutions, to be fair. So from like the app in the client's perspective or the user's perspective, which is right next to them. I don't know if this actually is a category, but this is the best different one I've thought about. Right? Similar idea based on, I would consider these triggers are based on, okay, so you're saying load resources based on events, client-based events. Yeah, that's an interesting one. I'm trying to think of where this fits because it's between load page and client-only interaction. It could also be under mutation server update. It's because it's the idea that doing a certain action in the client, like maybe mutation is wrong here. It's the thought that doing a certain action in the client would cause something to need to come from the server. Because like I say mutation, but it's like two sides. It's pushing something server to get something back, but that thing you push the server could literally be nothing, and you could get something back. Like I just saw. Right. I mean, this is a choice, right? How you handle it. You can guard yourself against this in either case. Right, to local data store. Again, the local data store is either going to be on the client, so categories here, or it's going to be on the server, so it's categories here. Even if the local data store is in the client, it's still on the server portion of the mentality. I don't care if the server is in your browser or if it's on the server. It's categorically, like shape-wise, kind of falls the same. So I think we're good. Yeah, 4 is basically, yeah. We is this. I'm just trying to say async. It's almost like client initiated async server communication. And this is, I guess, server initiated. But the only thing you have to consider here is that even with the WebSocket, the client has to open the WebSocket. So like this distinction is worth highlighting, but it's also, yeah. Updating UI depending on the state. I'm still gonna, to me, this still falls under 4. Like it depends. Updating the state and the UI dependent state is a client-only interaction unless it's not, and that's number 4. So yeah. Right. But like leave and revisit can happen on a micro sense, but I think it is important to talk, like, because leave you can say in the whole sense, but you can also talk about leave and revisit with, like, say, client-side navigation of going to a page and then coming back to a page, right? But I think we got a good list to kind of start with. Right. Yeah. So it can update synchronously, like omni to all. That's number 3 then. Okay. So I think there's a matrix to be made between these 3 approaches and how well they handle these activities. Right? I think they can all do some level of this. This is not that. It's just you have to think about, you know, you have to think about, you know, what it looks like. For me personally, the easiest one to start, like this is a good list, but I think it's easier to actually start this in a different order. I think we can client only. Let's move this. Let's edit the order of this list. I'm gonna order them from what I consider the simplest thing to talk about to the least simple thing to talk about. Client interaction seems to be the easiest to talk about, I think. And then I'm gonna consider mutation the next easiest to talk about. And then navigate to a different page. I'm almost like reversing the order. Probably the next easiest to talk about. And then loading the page is probably the most complicated to talk about. I don't know what to do with server initiated comms because it requires persistence on the server, which makes it not something that we can actually compare really easily, unless you assume that persistence on the server is available. And if you assume persistence on the server is available, then it looks really similar for all of them. So there's, like, if you assume the infrastructure is there, then there isn't much difference. And if you assume the infrastructure is not there, I don't know what to do with this one. This one's just going to be, we'll see if this is relevant. I'm glad that we were able to find a fifth category though. Okay, so everyone's still awake with me, right? We're still going strong? Yeah, okay, that's awesome. You could do long polling, but like you're still, there's got to be something on the other end. Yeah, I mean, yeah, I mean, Jose from LiveView actually had a good thing about this because he was talking about one of the reasons that LiveView works so well is because he can literally like ship up the VM, clone it, and like because of Elixir, he can just like move it across. So like it doesn't even matter if the server gets teared down or not. Obviously, there's things like durable objects and Cloudflare that make it easier for us to have it. But what I'm getting at is I think once that's present, we can all agree that there isn't much difference on the client side. Like it manifests itself as a, like once it's present, it manifests itself in the SPA as a state update. It manifests us on a server component as a state update, and here it's the mechanism that it works on. So like, yeah. Load a page falls in sync communication. Yeah, it does. But I'm specifically like what I'm talking about here is like I am trying to talk about like committed interaction. Like I am talking about mutations. Like the fact. Maybe we should just get into it and then we can see if the characteristics fall apart. Server initiated comms mean sockets, maybe it doesn't matter the architecture question. I don't think it does, except for like where it is the architecture. Right? So let's just let's just go here. Let's start with client only interaction. Okay, so I'm just like moving across the board. Client only interaction. I definitely appreciate you all joining me on this brainstorming session because it helps kind of think through stuff. So generally speaking, trying to think of how I want to arrange this because there's a lot of these little blocks that we're making. Maybe this fits better in an article, but I like being able to have this dynamics of moving around and thinking about this stuff. So client only interaction. For a single page app, it's simple, right? State ends up updating the UI synchronously. Generally, it's actually event, state, UI synchronously all in the browser, right? I don't think there's really much more to it. Right, and because for SPAs in this like this UI equals function of state essentially. I mean this is true for a lot of these, but doing these client only ephemeral, would you have it, interactions, it's pretty good. So if I was going to rate this between like 1 being not very good and 3 being like, very good on it, I'm going to give single page apps a 3. Just kind of like roughly say, because this is literally what they're built for. You have an event, do some state updates, IDate, synchronicity, UI function state. Okay. And if I were to talk about server components, I don't know if there's any other considerations here, right? Because the client components, like not all components can handle this, but like similar to SPA in client islands, right? So it handles this pretty well, right? Just kind of like thinking about this. If these are the things if you care about. Now stateful server. This is more interesting because generally speaking, if you know how something like LiveView works, are you guys familiar with LiveView? I'm just going to use LiveView.js because it's easier for us to visualize. But I'm sure there'll be like a simple example here. Yeah, beautiful. Way LiveView works is the server it renders stuff, and then they put special attributes that do event delegation. Essentially, it's funny because a lot of frameworks do this under the hood, anyways. But you see that they put a named function, and then basically when you perform the event in the client, they just go like send it back with the name of the event, and then because the state lives on the server, you can then like go, oh, count equals count plus 1. See, this socket here context is like the state. So this stuff happens all on the server, and essentially they have this like representation of your app on the server. The event fires in the client, which then updates the state on the server, which renders the part on the server that changed. In this case, they can be like, oh, count changed. And they basically do like a beat on diff essentially, and then realize that, oh, I only need to, send down this portion of the UI, patch this location with this new text value or whatever in their kind of diff format, and then the client updates, right? So it's a very clean model. It's as simple as a SPA almost, like, you can put your use state here, event handlers, render. The only thing is this happens on the server. So ephemeral state is more difficult here, right? Because the characteristic here is you don't want to go to the server. So how do you solve this with stateful servers? Well, you have a couple options, right? You can either, run it through the server, unnecessary, like server, which isn't what you don't want to do, or B, require secondary mechanism, kind of like a JS escape hatch. I mean, every framework has escape hacks, but it's kind of like on the same level as like using use effect with a ref, with React and kind of getting out of the model. It's not inherent to the model. You can obviously solve for this, but essentially you have to step out of the framework, or you have to be like given like a second approach. Like HTMX has what's it called? Hyperscript to try and like describe some stuff. And I think Phoenix has something with like that like tells what classes to apply or whatever. But what the key part is, the secondary mechanism is not tied into the state of the application on the server, so to speak. Like it's a kind of separate imperative API. So I think like you can kind of see if you're building something that was only client-only interactions, this wouldn't be really where you would want to be. All right. With me still? All right. Okay, get some water. Yeah. Okay, so we're going good so far. Okay. Let's go to committed interaction. I think that's what I'm going to call it. Committed interaction. I don't know. Committed mutation. What did I call this? Committed. What I mean is this goes to this. This goes to the server. Committed interaction. All right. All right. Now, this is when we actually go to the server and save something. Let's put these same categories here. I think this is where it gets a little bit spicier, from my opinion, from others. Because what does a committed interaction look like from a single page app? See, this is tricky because developers don't do optimal stuff, generally speaking. Right? But like in a single page app, you send a post request, and the most simple interaction, like you're just on the page, is you can send a post request and you get the data that you're missing. You hit like and you get the like count back. You add a to-do and you get just that to-do back. Right? This is how we used to build APIs. Like when you performed an update operation, you get the one item back. When you add an item, you get the item back with the new database ID. That is the most basic approach to that, right? Which is post to provided data, and then update state in the client, right? Well, now we do a lot of people do a lot of way more in unoptimal stuff. Like we do a post, get the thing back, and then go, okay, what do we need to refetch? And then we go, let's refetch the whole list. This way we don't have to worry about updating the state in 10 different places, or not even 10 places. So we go through the process of like revalidating things. And in a lot of cases, if you can do granular revalidation, it's not actually that bad. It's not as efficient as what I put here, but like TanStack query mentality exists. But double waterfalls are bad. So you can solve that with single flight mutations. But but that's still an extra bandwidth potentially. But what I'm so like not always completely optimal. I'm not doing this to bang hit TanStack query. I like TanStack query. I just want to point it out there. But like, there's also GraphQL on the client, right? Which can do granular normalized diffing if you want to. There's different solutions, but at the core of the fundamental core of the technology, I actually don't think SPAs are bad here, because you literally can send exactly what you need to send and get back exactly what you need. Obviously, we have ways to kind of make it more optimal or less optimal. And I'm going to talk about that later. I actually have a new proposal for Solid's actions that can get us back to bridge the gap to where we can do handwrite optimal updates without sending back all the data. I was doing that Trello demo, and while it was very impressive, Jose did have a point. We sent back all the data and I think that's good default behavior, but we can definitely make our actions not always send back all the data, so that from that perspective, there's no downside compared to what he was doing in his live view version. And that's like fundamental. This is not fundamental to the architecture at all. It's just a matter of like, it's still post get data back update state. So I know people might not agree with me, but I actually don't see any issue there. And if we're talking server components, well, client interactions can be like this, but what about data in server? But what about data in SCs, right? Like in the server component part of stuff. Because allowing me to, I learned a few weeks so that remix single fetch feature doesn't actually implement single fetch feature. Okay, that's interesting. I wonder what they're using it for. Because like you can group all the fetches together into a single fetch, but it makes it trickier for them to be separately cacheable. Or see, I mean, I was kind of like, posts are tricky too, being cacheable, because you post and then you get. I guess the thing is, I think this is where the conflict is. If you want to use like the CDN cache, you need the separate get from the post, because you can't cache a get. Whereas like if the grouping of the single fetching is always together, so you say like this page has this grouping of stuff, you can still CDN cache that particular combination, but it doesn't help you with fine-grained updates and revalidation. So it's like, yeah, it's kind of a miss. It depends on what you're optimizing for. I mean, it's fine if you're just trying to do the CDN thing, but you know me, I like optimizing for the like super granular. I like keeping cost off the server. Right. And then that combination becomes the unique cacheable thing instead of in each individual one. I think that's probably the argument. Honestly, mechanically, this makes zero difference. Splitting versus not splitting here does not actually mechanically do anything. I thought about this. Dan Abramoff was trying to like convince me of this. Unless you hit the maximum number of connections, then this actually doesn't do anything mechanically. Like it doesn't, yeah. Anyway. But my point is, if you update data and it's responsible, like say for rendering the part that's like updating the data that's like not in the interactive zone, then this becomes a much different scenario, because like, sure, in the small, like the whole point of this architect, like you could make your whole page a SPA in here in server components architecture, and then you're fine. But but that defeats the point. Then you just have a single page app. If you're actually trying to offload the work to the server to get the benefit, on page load and stuff we haven't talked about yet, you're going to do it so you don't have to send a lot of that data to the client. But it means that when a mutation happens, you are in this zone where you need to, at baseline, you're not just sending the data you need, you're actually sending arguably the HTML and the data you need for the client components. Maybe it's a subset of that data for maybe the whole page, maybe the whole partial, maybe the whole section, right? You're sending data plus template. We're going to be using these terms a lot. Code, data, template. I'm going to define these as the code being, JavaScript code. It could also be assets like CSS or whatnot. The data, which is like the actual like unique data JSON you need. And the template is the static part of the HTML that you need to put it together. Now, don't get me wrong. When you do rendering on the server, you're actually sending the completed version of the HTML, which from my perspective is the template plus the data. So every time there's a difference between, say, having the template live in your JS and you send it once as part of the code, and then you get the data to fill in the holes, and on every interaction sending the HTML, which means you're resending the template over and over again from a bandwidth standpoint. So what I'm getting at is, in this case, your template plus data from from bandwidth standpoint, and if you're hitting a singular endpoint, a singular piece, you have to pull in all the data for every piece of data. Like, let's say you realize that you've updated one thing. Well, because you're re-rendering it all, if you're stateless, you actually have to pull the data now from all the different data sources to get be able to completely render that HTML partial. So you're also like rendering, pulling all the data. Now, this is why caching is so important in these architectures like Next.js and whatever, because like on a single page app, you only ask for what you don't have and get what you don't have. So like you only get what you want. But with this kind of architecture, you basically have to always grab everything. So without caching to guard here, you're basically always doing more work on the mutation. It's like the physics of it, so to speak. So caching can alleviating, but my point is, for me, this is a 1, right? Right. We're not at load yet. Right. Oh, you guys talking CSR again? Guys, have I lost you all? Okay. So, and then finally, what's our last one? Stateful servers. What are we doing here? Stateful servers are, I think, pretty easy here, right? If we look at our live view example, update the thing, render the thing you need on the server. I don't know how granular the re-rendering is. Assuming it's like component level, it could suffer, but because they're preserving the state on the server innately, you could argue that like it's like when a React component re-renders, you have the previous state. You don't need to like fetch it again. So, and then what it sends back is the granular update. Like, here, update this, add these divs. Like it sends back a fairly optimized payload. It's arguable whether the optimal narrowness of that of being HTML versus JSON is better or worse. It's serialization format. But I from my perspective, it's a coin toss, right? Like, it doesn't really matter. Like it it's basically event, state, UI, async. It's like the mirror of this one. So these guys, I'm going to give a 3 here for stateful servers for committed interaction, right? All right. We're still good? You should put Subway Surfers in the corner. Are we still talking about offline first? Sorry, chat. You guys are really going off on the single flight mutation thing still. Okay. Okay, so let's go to the next section here. What do we got? We got navigate to a different page. This is my holistic scoring. I don't care about DX, if I've ever made that clear. This is about mechanically performance characteristics, capability of delivering on these features, in terms of within the scope of the architecture of the tool. As I said, if like giving live view or stateful servers a 1 on client-only interaction, yes, you can solve it by importing jQuery, but that's kind of like outside the scope of the tool. You can argue that's ergonomics, but I think that's philosophically on the outside, right? And here, when I'm talking about this is, you could argue that necessary caching is no different than necessary stateful servers here. So like you could argue that this is like not really a pull, it's just kind of a trade-off here. But fundamentally, this executes everything and renders everything and ships everything. It's the only one that has to do that in this category, where these two don't. Right? I hope that makes sense. I mean, this is my opinion, but this is basically how I'm attacking this. Okay. And when I say SPA, I mean the general sense. I'm talking about the SSR SPA, so to speak, or single page app. I'm not talking about, that's kind of like a given in this comparison from my perspective. So how does it work in a single page app when you navigate? Code splitting, generally speaking, so you don't have all the JS up front. So when you go to the new page, you have to load the JS and you fetch the data. And generally speaking, almost all route frameworks do this thing where they parallelize the code data fetching, and then the templates in the code, so to speak. So essentially, the first time you hit a route, first time you get template plus data plus code, right? And then subsequent times you get data, right? There is some overhead, arguably, you could say, of rendering on the client. But what's interesting is if the code, especially subsequent times that the code's already there, it can render ahead of time of getting the data and fill in the holes. This is maybe like a suspense type thing, but what I'm getting at is the cost of rendering the HTML on the client versus not, unless the size of the page is immense, is not going to be much of a detractor here. Right, this is why we do stupid stuff. Like, okay, like the actual physical rendering of the DOM elements. I mean, you can basically test this theory by taking inner HTML something versus like how long it takes to like framework render it. It's funny because I saw this all the time with streaming, because streaming SSR, we'd actually bring in large chunks of HTML and drop them in the browser. And when I used to compare the timings of these and the overheads, especially in Lighthouse, you saw that the page rendering didn't actually, like, streaming, the amount of work the browser had to do at the point that the stream did the chunk, almost even like giant pages, generally was a wash with the effort, the processing time for actually rendering with the framework on the same page. So, I mean, take that where you with a grain of salt, but I just want to kind of put that out there. Right. People can make waterfalls, but it's, again, not inherent to the architecture. Right? Yeah. I don't pay if you're talking about like full page reloads, that's the last category. So I'm if you think about this, I'm gonna give this a 3 as a baseline. We can come back to it and think about it to see if we think differently, but there's no inherent waterfalls here, right? Because you get, essentially, you parallelize all the data fetching from the knowledge from the first bundle. This is the cost of the first bundle. And then after the first thing, you get a more optimal payload as time goes on, okay? Let's look at server components. When navigating with server components, we don't have to worry about like manually parallelizing or hoisting, because you only just request the next page, right? So it's like single request for next page, which is nice. You just go, get me this page. However, the client isn't aware generally of which islands it's going to need on that next page yet, right? I guess it's possible you could serialize it into the page manifest. Generally, that goes against the whole idea of not doing so. Like, it's kind of an interesting conflict, because you don't actually know, because a server can change which islands get drawn, which server component. You don't actually have the code. Like, sure, you get the JSX HTML back to render it, but you actually don't know, like, you have to hydrate those client components when you render them. You have to like render them even, actually, with server component architectures, because they can rely on client context state. You can't actually render the client components on the server after the initial load. So here you actually have to load the client components. You have to go to the server, like essentially server fetch like static or like server components. So, which means it's basically data or template plus data, then waterfall fetch code to render islands, right? It's like we have this characteristic on the initial page load where you get the HTML back first and then you get the JS, right? And what's interesting, that's first time. Subsequent times, you don't have to worry about, you already have the code, so you don't have to worry about it. But you just get template plus data every time, right? So you save the waterfall, but initially there's a waterfall, and subsequent times you do both, which kind of fits into what I was talking about here in terms of bandwidth. The bandwidth here, it's arguable how, like, I'll consider it a wash, the difference between client rendering and having extra bandwidth to render on the server. But yeah, it's kind of an interesting problem with this waterfall. Now, what can we solve this to do this? One thing we can do But there's a waterfall. You're asking new page, and that page is served as a module from the server. Asks for new data that causes a new fetch. So which waterfall are you talking about? Does browser caching affect client-side routing once you have the code splitting happening or response change? No, that's what I'm saying. For client-side, afterwards, because the code's already cached, you already have the code and template. So subsequent times, you only need to get the data. Where on a server component, subsequent time, you have to render the whole output again. But you won't have to load that much smaller code bundle each time, and you get rid of this waterfall. Now, interestingly, preloading. See, I was going to give this a 1, right? This is just, it's fundamentally just worse. You're sending more stuff. You're causing a waterfall. But because preloading gets you around the code fetch, like if you hover the link and then they can fetch the code ahead of time to get rid of the waterfall, I'm gonna give this a 2. It's only slightly worse than SPA navigation, right? But yeah, I'm gonna say, yeah, preloading helps a lot. Necessary, basically. So necessary caching, necessary preloading. I mean, if you understand this, you start understanding why Next looks the way it does, right? Like the app directory. Okay. How about stateful servers? One thing you're going to notice about stateful servers, I think, throughout this comparison is just how simple the model is. Because since they arguably don't need any more JS here, because they don't have interactive components, they all handle on the server side, like basically the same things that penalize them over here act as a straight here, because there's no extra JS, right? They don't have to worry about this code waterfall because there's just no code to load, right? You could, it'd be fair to argue, I guess, that a single page app loads more JS, but because usually the data fetching is the bottleneck on a single page app, I'm not going to really think, like, usually when you parallelize, you send it up for the code and you send up for the data, and it's actually the data that's the bottleneck. The code is cached in the CDN, even if you haven't loaded it before in your browser. So I'm going to say, when I'm looking at stateful servers, yeah, they will send template plus data always, but no JS is a benefit. So like they take a hit here, but they balance it out here. I'm just going to give them 3 on the level, because I think it's essentially like one trade-off for the other trade-off, right? But mechanically, I mean, it's, you go to the next page, you have the socket already open, you just tell it what HTML it needs. It's basically like the mutation case that we were doing here at a like a sub level. So there's not really much difference here from the stateful server perspective between these two interactions. All right. Let's do right. Yeah, exactly. I mean, this is why Next has had a lot of challenges, right? They've been really trying to figure it out. Basically, you could argue that a user is a key to that cache. So yes, in some cases, it might mean a different cache entry for everything. Like you're approaching statefulness pretty quickly here. So yeah, it is an interesting piece, right? This is why there's been so much focus on Next and cache, because it's basically fundamental to it. Okay, let's go do the last category here. Because as I said before, looking at this now, I think that fifth category we were talking about doesn't matter between implementations. It's basically the same thing. Load initially, right? All right, just gonna put load page, whatever. Okay, so let's get started here. Now, so far, if you've noticed, single page apps have had a perfect score. There's no way they get a perfect score in this category, right? There's just no possible way, right? Like all the JS. I mean, it can be code split, but like all JS. And with SSR, double data, double template, right? Because you send the data both as JSON and as in the HTML encoded. You send the template both in the code and in the HTML encoded. And you have all the JS logic for, all the components. But this is just, yeah, this is everything. See, the reason I don't consider the JS overhead that much here is because most of the JS code framework can often, again, it depends how it's authored, it's often the templating code, right? Have you ever like gone into like Solid's Playground? And obviously logic here makes up space, but what I'm getting at is as your page gets larger, the thing that actually grows the most are these template elements. I think attaching the event handlers arguably as well, but over this size is giant. Like right now it's just a button, but this is the thing that scales with the size of your app. Everything else here, this scales with interactivity, right? If there's nothing interactive on your page, so like all things fair, comparing server components to a SPA, for example, then, I mean, if you think about it, then you don't have this code either. What are you rendering? Like, this is like if you're treating it under the same use cases, the code that scales without interactivity is just a template. So I'm not penalizing the JS so much for it. Like if I add like a div around this and close a div and then add, h1 and get the thing that's going to keep on growing is this, not the size of my interactivity of the component. This is literally just a call a function. So it's worth a call out when comparing to a certain degree between server components and like single page app type mentality is that the template code is a lot of the JS code, so to speak. Obviously, if you have advanced logic and you bring it in, then that will make the client larger. But if you also put that logic to the server using like server functions, you also have a way of alleviating that, so to speak. Like there's different mechanisms for alleviating that even in a single page app framework. Okay. But yes, yeah. Yeah, I mean, there's not much to say here. There's just no winning. Yeah. You have a sinking feeling that stateful servers are going to come off top here? Well, the thing is, maybe they should. Because the one thing, let's keep on going. Server components. Talk about server components. I'm just giving a score between 1 and 3. Like 3 is the best. It's very arbitrary, holistic view, looking at not DX so much, but looking at the mechanics from architecturally within these sort of architectures that we've been focusing on throughout the stream. I bundle a lot of these things under the same categories, where some people say, oh, these are different things. I'm grouping them in a way that I think is logical from mechanically how they work. Yeah, no, I've been just doing it out of 3. What it does is it lets me say, like, I don't really know. It's hard for me to articulate how much better something is. So 3 gets, like, the biggest one is 3 and 1 means like way better, but this gives us a place to say this is 2, this is a little better, this is a little worse. It's a little relative scale, which makes it less than a perfect science, because not all of these are weighted equally in importance, especially depending on the type of app you have, right? If we had 5, maybe this would be more extreme. I mean, we could try and rescore these to 5 afterwards, but let's continue here. Server components. So the funny thing about server components is less JS, sure, but there's still double data because of the serialization format, and there's still double data and double template. Funnily enough, not all the data, double. Actually, quite often all the data, actually double data, double template. Ironically, like less JS runs. So all JS. So this will load, and then all JS runs. Less JS runs. But generally speaking, I'm going to say, like, I benchmarked this. If you've seen my talk, the front-end existential crisis, I'm only going to say that server components are an incremental improvement over a single page app. And to be fair, yeah, I mean, I'm just going to put that as a baseline. Okay. There isn't really much else to say here, I think. And then stateful servers. This is interesting because there's nothing to hydrate. Is there? They just need to, like, basically attach their event delegation system, right? Event delegation, done. If that sounds familiar to you, there's another approach, the resumability, that does this as well. So event delegation is only hydration, really. There is this like long wait up time with the WebSocket connection. I know you can HP2 back, but it was noticeable when we were testing stuff with LiveView. We could tell that there was that time period. But I'm going to throw out there, and I don't know if LiveView already does this, but they could. So architecturally, this is a thing. They could use event recapture the same way we do during hydration with Solid and React, and just play back those events, and the connection time versus hydration time is probably comparable, and they have like way less JS, no double data, no double template, because they don't need to send that stuff. So like I mean, how is this anything but a 3, right? Like, even if there was a delay hooking up the socket, the same tricks that we use to mitigate, progressive enhancement, all the stuff we use to mitigate hydration still works here. So, yeah, I got to give them the thing. If you don't SSR, there's no point of run replay. Sure, but I'm comparing these to SSR. If maybe I'm talking SSR SPA. If I was not talking SSR SPA, the client-side app would do good here, do good here, do good here. This would be like, if there was a 0, if there's a -1, yeah. Anyway, that's basically my graph. Should we tally stuff up? Let's see where we ended up. Totals. SPA, we have 3, 3, 3, 1. So respectable 10. Server components, 3, 1, 2, barely 2. 2. So I'll give it 2. So 8. Now this is equal weighting, right? And stateful server 1, 3, 3, 3. What do you know? 10. All right. So, I obviously some applications care about page load the most. Some applications are incredibly interactive and probably care about this part the most. This doesn't show all that much, because all I'm saying is that the thing that dedicates the most towards its side ends up, if all things are treated equally, end up being the best, and the thing that compromises in the middle ends up, being a bit more leveled in certain places, but ends up ultimately, if all things are equal, not being the least, Is it any iron that DX5 scored lowest and boring came out on top? I mean, not. I don't think so. I mean, I would argue here from a developer experience standpoint that when I consider all these use cases, like you can see how little I had to write here. And you can see that here we start getting more here, but this stayed kind of simple. Stateful servers might have a win from like just how straightforward the like pure DX aspect is. There's more complications here. Clearly, server component model has the most considerations because it's juggling both sides of things. But also, as I said before, stateful servers are basically a non-starter for probably the vast majority of people building sites and apps. So it's like the thing you don't get to use, but it is interesting. And here is the question, right? Do these things have room to grow within the mechanisms of their model? Because I gave SPAs a 1 here, but we can definitely get rid of all JS and all JS runs. Double data and double template is kind of inherent to us. I don't think we can actually solve that. But if we fix this, I wrote these two to be similar for a reason, because you could argue that some type of optimal hydration, like what Quick does, turns this into this. Suddenly our SPA mentality single model is basically the same as server components on initial page load. Suddenly this actually becomes an 11, right? So yes, there is room here. So that's one place where there's room. Let's look at stateful servers. Do they have the potential to do client-only interaction? I think they do. There might be a place to combine the model. I'll talk about it later. I actually have some ideas here. So there might be a way to up this, right? How about server components? I don't see it yet, because you've already gone through the details and realized the trade-offs. I think server components actually have, they could make this maybe into a 3. I think it's theoretically possible. I've talked about this before. I think server components have the possibility to solve double data, double templating. I think it's very, very hard. I think there is a world where they can get to a 3. That was my premise why I was so into server components a while ago. I thought it was easier to make this a 3 than make this a 2. I now am not so sure. I think it's probably easier to make this a 3, or I think in order of easiness, making this a 2, making this a 3, and making this a 2, I think is in roughly that order. I think, yeah. Yeah, I mean, don't get me wrong. There are restrictions here, types of apps. I don't think stateful servers are an option for most people. So, like, I'm just talking purely architectural. If you had infinite money and infinite machines, and talking mechanically what it does, it is attractive. I think in reality, a lot of people can't choose stateful servers. The more interesting comparison here is I actually think single page app mentality might be easier to grow, right? The question is, it all comes down to like page load for the most part. And as I said, I like Solid's already pretty optimal here. Quick's even more optimal here, enough that I would say Quick bumps this easily to a 2. You start, there's other DX trade-offs and stuff, but you start actually asking about comparing the model. Yeah, obviously there's JS consideration, loading consideration, but fundamentally the architecture's like when it sends template and data, I think those are fundamental parts of the architecture. Those aren't the things that you get to correct. Being able to be more optimal around knowing to send less JavaScript, these are things that are optimizations and aren't fundamental. So there's room there. It's arguable that here they could put the manifest for the JS components for the next page, in the client, make the client bundle bigger. Like there's places where I could see trade-offs, but then you go, those trade-offs don't make sense. And also I don't have a crystal ball. I can't predict the future. So I can't rule out all possible things. But like this was the one that turned me off server components. When I was like looking through this, I realized that server components were not what I wanted for most things. Server components are really good if you don't care about mutating. If your data, basically, if you want to take some other kind of conclusions from looking at this, let's think about some conclusions here. From like use case. If you care about page load, you probably don't want SSaA, but it could get better, right? If that's your primary thing, right? This is like why Astro does so well on all those like web things that they always post about, right? Other observations, like obviously, like in my opinion, the stateful server wins, but that's not obviously an option for everyone. Interesting thing, if your primary content changes rarely, server components are attractive. Or another way to phrase it is, if your primary content changes often, you probably don't want server components, right? If you're heavily interactive, you probably don't want stateful servers. That's like the most generic kind of conclusion you can see from this, right? I don't know. I think everyone knew about the first and the second one, but I don't know if people understood that the weakness of server components is actually mainly around how often your main content changes. Right. You're saying if users share ephemeral state, stateful servers are attractive. Yeah, I mean, it's basically, yeah, I mean, there's certain things like, as you mentioned, multiplayer, you need stateful servers. But this comes to the question of like, architecturally, that add-on can be like, you can add that to any of these architectures without that being like, that aspect of it is just like, oh yeah, now I have blank plus WebSockets. The key here is like from yeah, I mean, I did maybe keep this to, like, if you're going to go to WebSockets anyways, then one that has it built in looks attractive, right? Right? I actually, how maybe heavily interactive this thing. If you, it's not heavily attractive. It's like low latency, heavily attractive. There's other reasons not to want stateful servers too, and there's other reasons not this. This is kind of, yeah. Yeah, I mean, it's not about part of our problem is like there's a lot of JS devs out there, but I think the bigger thing is like stuff like serverless is kind of pushing away from stateful servers, right? People trying to scale large apps, they can't afford to keep connections with everyone. Now, there are situations where that makes a ton of sense, and I know Elixir scales like mad, so like there are potential there. So maybe, yes, certain languages definitely push you there. If you try to use Node, like I know Live.js did it, and Node is fairly good at non-blocking async. But like I can picture like it probably doesn't hold a torch to like, Elixir or whatever. And I do think there are considerations there from that kind of perspective. But yeah, I don't know. I can only really, this is very theoretical space. Right. But it's interesting. Can you change these? I think this is also kind of reflective where we should be thinking, because can we change these aspects? Like, if you care, you probably don't want to SPA, right? But the thing is, can SPAs improve their initial page load characteristics? It's possible, right? These I think the other two might be harder. Is it easy? I mean, you can come up with other systems, but within the realm, it might be difficult to improve how like low latency, like non-async is for stateful server type architectures or state first. If your primary concern is how often your content changes, like you can't control how often your content changes. So yeah, I think it's interesting, right? Anyway. Network, I mean, yeah, but a lot of these architectures are not going to work great with network consideration. Like I don't want to penalize too hard there. Definitely. I think the biggest thing people don't realize, the server components are doing a lot of inefficient stuff when it comes to when they actually do the rendering on the server, which is not that inefficient in the scope of things. If your baseline is like MPA, guess what? MPA is, you do something, you re-render the whole page. So who cares? You're used to that. But single page apps and these stateful server approaches have really optimized along the vector for change. And I think that is kind of where the difference is. SPAs, yeah, SPAs with optimistic updates work well on bad networks. Yeah, they work decently well. It's kind of like a mini offline first bucket. So, to a certain degree, like obviously if you're trying to do something too big, but it'll give you a little bit of leeway, right? That's why scoring high here is good. I mean, there's so many aspects here when you consider like versioning, tearing, cacheability and stuff. This is just like one exploration. I just wanted to kind of put it out here because I think that that maybe single page apps have a bad rap. Maybe it depends on what, like maybe page load is what's getting pushed here so hard, right? The thing is, if page load is everything, to be fair, it's worth caveating here that if you pure islands, I should add this here, pure islands are 3 here, pretty much. They do not suffer from this. This is the client-side routing is what makes this challenging, right? This is why I was very interested, because if you could get this 2 to a 3, then like that's one way to bump the numbers a little bit. I realized conceptually, because of this, that I no longer like them or cared about them anymore. This was the blow, not this. I even getting this up to the 3 still, you know, still is below the others on average. But if you care specifically about this is your segment, then this is probably a pretty reasonable way to go, especially you know, if a lot of the complexity is kept out of your way, like it is in something like Astro. Would you even? Yeah, I mean that's the thing. I mean I didn't put it here. I said this would make it this -1, but this client rendered single page app for all of these, except for this one where it's worse, is essentially still 3 throughout. Like client single page app, maybe on average is an, by this grading scale is a 9. It's still on the full range of operation for an application. I'm not talking about sites. I'm not talking about like places where you only care about this. It kind of averages out pretty decently. Yeah, but yeah, in this context, I'm including SSR. But the only place that it actually makes a huge impact is here, and it's already a 1 even with SSR. I mean, in a sense, SSR is just an optimization to a sense. It does put other constrictions in, that we have to think about, but it doesn't fundamentally change the architecture. All right. So I don't know. It's interesting. How we doing, chat? You've missed so much. You have. I don't know. I think there's some hopefully some hidden gems in this, and hopefully when we go back to this original table, you can kind of see how the spectrum going. I think we have a tendency a lot in JavaScript to underrate this section. The section is actually kind of impressive. I think there's a lot of walls in the way of it. I think there are places where this fits really, really well, but as the general architecture is very difficult to deal with certain types of things. And then this has a real cost that we need to figure out how to mitigate. So like none of these are easy problems per se. But I think in talking about this, we have talked about pretty much all of the different types of technology you could be using to build a web application today. And hopefully this isn't everyone's conclusion. Back to PHP. Okay. Which graphic? All the graphics? Or just this one? I mean, someone could probably screen share it too. But yeah, I could probably export this somewhere. It's in the pod. That's my answer for everything. Yeah, there's a fact that there is like extra overhead to it. The interesting thing is, yeah, with static site generation, there's even ways to optimize the CDN delivery of certain things. Yeah, I don't know. It's interesting. Yeah, this is probably the real hit. Yeah, yeah. Like there is an added like there's a whole other environment you have to worry about where things are running. There are benefits to SSR single page loading that go beyond, SEO. There's a bunch of benefits. Timing with waterfalls. One of the problems with client-side rendering is it's almost all in this first category. Like I didn't even get into it, but like you can server render preload tags into the page to reduce, like help reduce one of the waterfalls, because otherwise you get in this place where like even with code split routes that you get other code split, like you have to load the bundle before you realize more JavaScript to load, because you don't know what page you are on at the time you're in the client. Like that's why I was saying if I could put client side SPA as its own category here, maybe do the same thing I did with Pure Islands, go CSR SPA, it's going to be like -1. But and this is the problem, right? A lot of people's frame of reference is they go, oh, my React app. They think this. So when they think single page app, they're just like this. And then they're comparing it to something over here. And you're like, this is an amazing win, right? I think this gap, I think there's a lot of potential here in different places. Yeah. Do lakes add any benefits to spas? Yeah. So I snuck lakes in under here. Yeah, all they are is instead of sending JSON, you're sending HTML essentially, right? They're inert server components. So you saved a bit of JavaScript so you didn't have to render it on the client. So it is a technique to ship less JavaScript, but it's also only really useful for things that are not really interactive. So it's only a subset of what you can do with a proper server component scenario. Like, yes, it's, and there's a lot of places where now you're sending the template, which is static, right? Think about it. If it's basically static, I mean, it doesn't necessarily mean fully static. It could change every time you hit the lake. So that's fair. It's just not interactive. Yeah, I don't know. There could be scenarios where you have like basically all static part and it would make sense, but it's kind of like a hyper optimization in the sense that it's just like, it's kind of like having a spa and like loading an HTMX into the middle of it. I mean, you could completely do that, like create resource in Solid, render HTML in an endpoint, and then have the signal basically inner HTML it as code, like ta-da, This is why I sometimes joke about, HTML partials isn't like a framework. It's just like a basic tool, right? I mean, no, I like resumability already gets the benefits. Like the resumability already assumes that the outside is server until it needs to render it. It's kind of awkward. You actually need to denote boundaries for where client interaction could happen if you want to get that benefits. It's more like you actually need client components, but then have those client components not load all their code. Is actually, if you want the solve serialization, where you'd want to be. But you start seeing why this is kind of a mess. Okay. Let's let me see what else I have in my HackMD drawer, because I think I want to move to the next topic. Semi-related though, unless anyone has anything else they want to add. Yeah, exactly. I mean, ta-da, The funniest thing is you might even, someone was trying to serialize SolidJSX and it didn't quite work, but you could basically use our JSX in an endpoint, like in a server function, and then like if you know about the hidden property in it, you could probably like snipe the rendered HTML out of it. Anyway. I think resumability is a topic worth considering in terms of that optimization space, right? As I said, I don't feel like it actually changes the architecture. It's still single page app mentality, perhaps, but it does. It has the ability to change the math in terms of the cost of initial page load, which makes it very interesting. Okay. Yeah, so I wrote a lot of articles, HackMDs this week. I want to talk about a few of them. Actually, no, this one's not new. I actually fixed a typo. I don't want to talk about resumability without serialization, but it came up because I have something else I was looking at. First thing I want to talk about is we're going to talk more about, I got three of them basically. I have something where I want to talk about optimizing past single flight mutations, talk about the role of caching APIs. And I'm going to talk maybe a bit about Next's use cache. And then I want to talk about stateful signals. So I have, so talk about stateful servers with signals. These topics all three of them are pretty interesting, but since I just did a heavy one, I'm going to bang out a couple quick ones first, and then we'll get to this one. Yeah, we use it before frameworks. Yeah. Server signal sounds very interesting. Yeah, for sure. Okay, so let me start off with this one because it's a quick one. If you've ever used like TanStack query or similar, and we talked about this on stream, you're probably familiar with the whole like do the mutation, add the to-do, and then get the response back, and then be like, I mean, we might have even drawn this somewhere on here. Not this one. Just see if I have it in. I changed computers, so oh, is that it right there? Is that you? No, this was talking about PPR, so it's not there. Okay, never mind. Okay, it doesn't matter a whole ton. We've talked about the typical. In fact, actually, you know what? I can grab this from my talk. View your channel. Where was it? My last V talk. I should just like pull out my slides. I should just pull out my slides because honestly, I just wanted this image, right? Right. Essentially, typical, you do a mutation, you go, yes, it succeeded, revalidate to-dos, send that data back. This is your typical, these days, double flight mutation story that we do in most frameworks. And the reason we do it is because it's freaking easy, right? You literally just give it a key and call it a day. You just go, okay, I'm going to update something on a to-do, just give me the to-dos back. And then because the way these things wire up through the cache, everything in the UI that's based on those to-dos updates automatically. You don't have to worry about manual cache writing. And it just makes things really easy. Remix loaders are the same. Almost all meta frameworks have picked up a pattern like this because it just like removes all the like fiddling with stuff. It feels very UI equals function of state. You just like essentially say invalidate these things, update the UI. It's very nice. Obviously, single flight mutations moves this interaction basically to the server. So instead of sending back the acknowledgement, the server at this point goes and takes that redirect stuff because it already knows, revalidate, and then only sends back the data. I'm pretty sure most people who watch my stream have seen this stuff before, but sorry, I'm on the wrong. Let me get out of this. But like, let me see what's an example of this. Let's see if I can find Strello. Not the app, Strello, GitHub. Perfect example of this is if I go in here and this, is it server TS? I can't even. I'm trying to remember where. No, I think it's in, you guys put it in with the components. Note. Yeah, okay, there's a bunch of actions here doing database stuff. My point is here it goes JSON, true, which is just the ACK, but then it goes revalidate this key. And because this whole action happens on the server, create note, even though we're sending back the information to the client to revalidate, we actually know here on the server and we can revalidate. We can fetch that data and send it back on the same request, right? So, and if I go to the actual Strello board, which hopefully is still up, can't even remember. I actually don't even remember what the password is here. Okay, it's still there. Beautiful. Tells you how bad that password is. Okay. If you go here and you watch what we actually do over the network, well, we got these crazy optimistic updates where if I go something like change it so that, where is the, should be a way, yeah, no throttling. If I make this like super slow, we can still move this over here, move this over here before these things even finish processing, and we have a snappy app with the optimistic updates. But what you'll notice is, and they're only a single flight. Like if I go here and move here, there's only one request made. It's not doing the double. But if you notice, we're actually sending back the whole freaking board every time we do a mutation, right? This giant payload of the whole board. It doesn't matter what I do. If I go in here and go AS4, guess what? And I can turn off, go back to no throttling. It's the whole board getting sent. Sure, we do a quick data diff and no components re-render, but it's a little bit wasteful for something that changes all the time. I think it's fine, but sometimes you don't need to send all the data, right? That's basically where my thinking is going here, right? So what if you, right, you can always tell it not to revalidate, So let's reference another being called it. So I came up with this kind of idea. I mean, maybe I'll get to that later, but how should I put it? Yeah, it's a tricky little dilemma how to phrase this whole thing. Basically, one of the challenges is that this site works. If I go here and go P and then I go disable JavaScript, okay? I'm disabling JavaScript. Now JavaScript is disabled, okay? When I move this card over here, I think this one, does this work? I'm trying to, maybe the drag regions don't work? I thought it worked. Huh. Are the trigger, oh, it's because of the triggers for these. Maybe this one isn't progressive enhanced. It's funny because it's based on the remix one. Maybe this one isn't actually progressive enhanced. That's interesting. I have to consider the progressive enhanced case. Let's enable JavaScript. Interesting. Yeah, I mean, drag and drop I get, but it doesn't look like we bothered, because the functionality is not there, we didn't bother implementing any of it without JS. But my point is, if our to-do MVC example I could pull up, it works in Node.js, you have to make the handling declarative because you don't have any chance to run JS. You can't go on action complete do blank. You have to instead go, our action feeds into a submission that we then can show as part of the next UI, kind of like a flash message, if you know what I mean, in Express classically. You need to actually write it into this data object declaratively and then use that to render the next page. You can't just go like on blank, do the update, which is tricky because you want it to both work when optimistic updates, or sorry, when the JS is available and when it's not. In this case, we don't care. But for me, generally as an API, I have to think about that. So I came up with this idea. I haven't implemented it yet, but I was thinking, what if you could tell from like a get method of something that you can run in server functions, whether you're running under a Node.js condition. And then if there's Node.js, you just can return like normal and not worry about it, because revalidation doesn't happen on Node.js. It literally re-renders the page. There's nothing we can do about it. But you could basically have different behavior based on whether you're in the situation where it's currently being requested on where there's no JavaScript, or in the situation when you know that there's a client that can handle stuff like the revalidation. And in this case, what I was saying is we could say, don't revalidate and send back the to-do. So that's kind of interesting, right? Because now instead of sending back all the to-dos, we just send back the one to-do we added, for example, or the one to-do we updated. And then if our action API had the ability to put in like an onComplete hook, we could look at the submission and go, oh, if it's not errored, let's get the key and maybe write to the cache ourselves, clear the submission out, and then revalidate false. And what revalidate false, this already exists in the router, is a way of saying trigger all the reactivity, like basically commit it and update all the signals that listen to this key in the cache without refetching. So essentially we manually update the cache and then trigger the update in the UI. This happens in a transition, by the way, or transaction, whatever you want to call it. So with this sort of API, when we did something like Strello, sure, like stuff that moves the order of multiple cards, you might need to send all the data back, But if you're just updating this from G to GGG, there's no reason not to just send back only the one record, only go like, hey, this now only has GGG. And instead of, doing a heavy diff, we could just patch the one update. Interestingly enough, because of optimistic updates, the value would be the same, so that no actual work would get done. But just as a mechanism here to actually reduce the network bandwidth, right? Instead of always sending all the stuff, right? As you can always return something. Generally, it's not recommended to return the data in an action because you fetch it again. But with this mechanism, you basically could. It's just something I'm kind of proposing. That way, people who are hypercritical about optimization, obviously this opens you up to be more error prone. You'd have the potential to be able to use actions, benefit from the routing redirects, do all that kind of stuff in a way that doesn't impede on your ability to send less over the network. As I said, most people haven't cared about this for a while because of the approaches they take with TanStack, but it's good that cache writing, in a sense, or at least revalidation, could be another tool that you have available to you. Right. This is only for people who aren't satisfied with it just works. Yeah. What happens when I queue update and delete action in this case? I mean, I'm not quite sure following the question. Are you asking what happens? Let's see, does automatic delete work? If I go here, okay, I'm not quite sure. So move. delete? They're both still in flight? Well, I mean, I don't know. Yeah, I'm not quite sure the question. Well, why send any data back? Well, yeah, you're right. This is the funny thing. With the Strello case, actually, we don't need to send any data back because technically speaking, yeah, it's an interesting one, right? Because we already have all the input. So if you look at the API here in onComplete, you have the submission, right? So instead of sending using the result, you could use the input from the submission. So like onComplete, you go submission.input and just set the cache with the input information. So yes, you are correct. In this case where you have all the information, like the Strello demo, you're right. I don't even need to send it back. I can literally know that I did a update to do or add to do, and I have all the information here, and I can just set it without even looking at the results. The result can be empty. So you are absolutely right. In this case for the Trello demo, we don't need to send anything back. Right? But a lot of times that's not the case. But yeah, something like a like button, you could literally just be like, I mean, you could just be like onComplete submission, is liked or whatever, like the Boolean submit argument 0, I think is submission input 0, and just set the cache with that and call it, and then you don't have to send anything back. Yeah. So yeah, good point. Yeah. So this is just one of those things that I kind of thought about a way of extending it. So told you that'd be a short one. Let's go to the next one. Dev, I see you're still here. I wonder if we'll get to your stuff in time. Hopefully we will. Because I got one more before I get to it. You need to send data back from that feed and like a service to say that you can't do it on the client. Yeah. Flight's in an hour. Okay. Okay. Advanced caching with router APIs. It goes without saying, I think we need to rename the cache function in Solid. I'm going to rename it to query, I think. I put it open in an issue, like an RFC, like for the router, like 6 months ago. A lot of feedback and different stuff. I don't like the name cache because most people think of cache as a cache, and our cache is actually, it does revalidate, but it doesn't actually stay very long. It like literally, I think it's right on the Solid router docs. Solid router, the GitHub. Our cache function, I made a point here of like what it does. Data APIs. Where is it? Multiple paths, nested routes, blah, blah, blah. Preload functions. Data APIs, cache. Okay. This cache comps as follows. It does deduping on the server for the lifetime of the request. It does preload cache in the browser, which lasts 5 seconds. When a route is preloaded on hover, or when preload is called when entering a route, it will make sure to dedupe those calls. We have a reactive refetch mechanism based on keys. So what we can tell routes that aren't new to retrigger on action revalidation. This is how we trigger the signals. It will serve as a back-forward cache for the browser navigation up to 5 minutes. Any user-based navigation or link click bypasses. So if you're on a page and you go to the next page, we don't read from the cache, we fetch fresh, always. It's only if you use like the browser back or forward buttons that we read from this cache. So this is the most unobtrusive cache you can pretty much imagine. It basically is not a cache. So calling the cache makes people run away from it when really, literally everyone should just be using it. So for the rest of this conversation, I'm just going to call it query. We thought about calling it data, people dedupe, but really I needed a pattern, a balance. Like there's action, which is like something that you do. Cache is not what you're trying to do. Deduping is a side effect of what you're trying to, like, it's the get. You need the query and you need the action. Tanner had good naming. We're going to stick with that. Yeah, this whole conversation is how I want to rename it. right? The interesting thing is like it's multi-set. So you could loader maybe, then you have multiple loaders. Yeah, I don't like the word loader. I don't know, something about it. Because the Remix has kind of made loader, I guess you could have multiple loaders. I don't know. When I think of loader, I think of like Remix's singular loader. And the thing is, this is key based. Like when you make a query, you basically say, fetch this thing and tie it to this key. So yeah, I mean, it has all the characteristics, base characteristics, I guess, other than the cache part of what, say, TanStack query does. Yeah, they have multiple loaders. Yeah, fair enough. There you go. Yeah, for us we don't care where the source is coming from. We're never going to have like multiple loaders. We're literally just having a generic mechanism that doesn't care where you fetch the stuff from. So basically, I named it cache originally because I was thinking that like React had the cache function. It seemed really practical. And I knew that create async was going to go core, in the framework. It's our async primitive. But over time, I've kind of decided that the cache thing isn't core. Query and action don't belong in the core. They're like a router thing, so to speak. So I was trying to figure out, what if you wanted to add your own caching on top of these kind of wrapper APIs we do? Like, what if you said you wanted to cache? And something occurred to me that I think is important for people to understand. Do I have Strello open? You can kind of see it visibly right here, actually. Do any of these ones shorter? Yeah, delete note's shorter. You go delete note action blank use server. Let me see, actually, is there a cache function in here? Maybe add note. A lot of these are actions. I want, maybe it's the board. Create store. Okay, so it's not here. I did not author this, but I know that somewhere here there's going to be a cache function. There's the action, preload, fetchboard. Fetchboard is what we're looking for. It's the benchmark, fetchboard, lib. It is the one thing that is in lib, where we started. Fetchboard. Okay, here, get user. This is fine. I just want to show a cache function generically, right? You have the async function, which is a server function and has a cache key, okay? And the reason that I wanted to kind of show you here is, the cool thing about the wrappers is that cache and action take something that's completely naked. Server functions have no special semantics other than they just run async on the server. They don't care about routing. They don't do anything. This is always a problem I had with Next, the approach, because they made it like server actions. They didn't just do server functions. Now I hear that they backpedaled to server functions. I'm not surprised. But the wrappers let us add extra ability. The only challenge with this wrapper approach that I didn't realize or think about very much at first is, when does the code actually go through the wrapper? So the thing is, server functions, when called on the server, you're calling an actual function. You're going call get user. It's calling this reference. It goes through the cache, and you get it when you're rendering. On the client, you're also calling this function. The server function itself gets hoisted out, but essentially you're calling it through the cache. So whenever you're rendering, whether it's on the server or the client, you're calling this function, which goes to the cache. But when you're in the client, or sorry, on the server, when you're calling, like the server part of when you call it from the client. So I'm on the client calling get user. The cache is in the client. When I hit the server endpoint, it's going directly here. It is not going through the cache function. The endpoint begins here, right? Which is different than rendering. Rendering, it goes through here, whereas the endpoint's here, which means that simply taking cache here and putting like, our query is what I would call it now. I'm going like wrap it with cache, like putting some wrapper on the outside would only ever impact rendering. Which means that only could you cache something on the server through this mechanism during rendering. So like if you wanted to say, pretend you could cache in like a KV store the response of this whole thing, it wouldn't work when someone hit the endpoint from the server perspective. It'd only work if they were actually rendering and calling this function. Does that make sense? For server components, the get is always called during rendering, so it always works. But for a SPA like API style, the get can be called from the server independently of the render, which means this is not the right solution for caching for the server. Yeah, this is just not part of what we have to worry about. So it means that when we talk about wrappers, we are literally only talking about adding caching capability like you find with TanStack query or SWR on the client. This can be the scope of what we can talk about. So I started thinking, okay, well, first thing you gotta understand is that technically our cache function, our query function, actually serializes the return value from it automatically. This is why it just works. Create async also serializes automatically, even without a key. This is just so that if you ever do any create async on the server in Solid, it won't run again during hydration, right? So I was trying to figure out like where do you put the wrapper then? You can't if we look again at our code here. Obviously, we can put something on the inside here and then it'll always be on the server. But if we're talking out here, do we put the cache, do we put your custom cache here or here? Do we put it around the whole thing or around your function? So I started kind of spitballing it out and I was like, okay, well, what happens if we wrap it around the whole thing, right? Outside. So if you can picture, you can go forever cache my query. Okay. And my forever cache implementation is really dumb. It's literally just an object that once it gets a key, it never deletes it. So it will always go like, what's cool about this approach is because you're passing the query into it, you can just ask the query for its key from the args, because all our query functions or cache functions, whatever you call them, have methods to get the keys off them so they can feed into actions. It's very convenient. So you can go like, when it calls the function, you can get the key for the args, then use that key, look it up in our object. If it's there, just return the value directly. Otherwise, call the query and put it in the forever cache. Really simple approach. The only problem is, does this work? Well, it works with hydration because if you think about it, the way this hydration ends up working is create async runs first. It sees the serialized value. This should be an arrow. I don't know why there's a plus there. My bad. It sees the serialized value and it actually doesn't run this, funnily enough. But on the next update, this already has the value preset because the serialization will have read it, put it into its cache. So technically this works fine with hydration because it just never gets to it. And then when the next thing hits, it'll be fine. So like if someone triggers a revalidation and then, or triggers something like, it's very rare case, but if someone triggered a revalidation, but not a refetch, just trigger the signals, it would see the data there because even though this would miss, my query would have it cached internally. So this works. But how does this work for revalidation? If forever cache always intercepts on the outside here before running it, it means that it's possible for it to shortcut before running my query, which means the reactive validation gets bypassed. So if you navigate to a new page, the first time, it doesn't have anything, and it'll read the signal and like set it up and get it in. Then you leave. But when you come back again, it will read it from the cache, but not read reactivity. So any triggers won't trigger again. It basically has detached it. Even if you were manually trying to like replace the cache in both locations, I mean, if this ever was a hit, it would unhook the reactivity essentially. So wrapping on the outside just doesn't work. Right? It's a funny observation. Code organization style needs to be optimized for Ryan streams. Okay. So do you put on the inside? So you go query, forever cache, fetch user, like this. There's first problem is you don't know what the key is. So do you have to come up with your own key utils? Because what you're getting is just a function. It doesn't know, like the cache key belongs to the query thing out here. It doesn't know when it calls your function. So you have to like figure out your own cache key. Revalidation at least works because it will always try and hit the query first, and then if it misses it, it will ask your cache. So at least it flickers properly. Right, and I was just commenting that you could like, obviously, if you don't like this kind of extra wrapper approach, you could always like just make your own wrapper, putting them two together. That's not right. But hydration becomes a problem because it's on the inside, which means it will never run, essentially, like I said before. And unfortunately, there's no way for this to get the cached value from this query, essentially, because it's on the outside. You'd have to like pass in the previous result. Like it doesn't work. Like it doesn't have the value if it ever gets in here, so to speak. Like, sure, you could say on the very first time after hydration, if the same thing got hit again and it never hydrated, like it's a very rare case that you want to ever get past here. So like I imagine if someone was like building something like TanStack on top of it or their own wrapper, they would do it this way. But you're throwing away the data serialized from the server the first time. Like, as I said, our query cache here is very short-lived. So if it gets past that and gets to here, it's not going to find the data. It'd have to serialize itself. There's no way to basically have the data present here from hydration time. There's no like on hydrate, like it's inside, it's not in the right place. It's also worth mentioning that the difference here on the outside is when we call my query, what we get back is resolved. It's handled the router redirects and everything by this point. You just get the data back. When you put it here, your forever cache is going to get whatever stuff that query is expecting into the router. So it's not a very useful cache perhaps, because like it could, stuff that the query handles for routing for you is already been taken. It hasn't been taken out yet. So yeah. So you're saying like if you put hooks on the outside, couldn't you revalidate? Yeah, the trick is if it doesn't read from the cache, the signals aren't present. Like if it like my query, when you run it, basically has a signal inside that gets tracked by the create async, so that when you flick it, create async reruns. If you exit early here, that signal never gets tracked. So I don't think this even does it. So then you get into this zone, like maybe you just add an option, like put the key on it and like have an optional action option object. So a couple options there. What I I played around with a couple ideas here. One is we can just like have our own rules, like TanStack, and put expire time, stale time, and assume that it basically is just something that lasts as long as the page. But then, maybe configure when back cache versus not. But basically, you'd have to have every possible consideration configurable, and I have no clue what weird behavior people want. The other option, I think, is to provide a mechanism that has a get and a set. Get with the key and the intent, and then set with the key and the value. And the expectation here is that on miss, it tries to do the get, and then on set or revalidation, it will tell you that you tell it the set. Like basically, the query always is in control of revalidation. It goes like, yes, I need to revalidate. It will handle it. Like when it's explicit revalidation, your cache, it participates. It can't override it, but it has the ability to get in the way of get. And based on the intent, whether it's browser navigation, whether it's this preload, whatever you want, you can make a choice on how to handle if it is a hit or a miss. Challenge here though is, should this be async? What if using like local storage, right? What station when I would solve router query versus replace it? I mean, if you want to participate in the actions, essentially. Right? Like if you want to play part of this key value thing, I mean, I agree this is getting kind of out there. I was just looking at extensibility. In the end, this seems messy. The fact you can't easily do this myself does trouble me. When I create a resource, I'm really concerned about how something like solid query would extend. I think create async is more flexible in that manner, but still might need an on hydrate hook. But I see that this exercise, that purely hawk-based approaches to caches don't really work. Like you can have one wrapper, but composing them is a mess. Also, none of this solves server-side cache. While writing this post the last couple of days, I recently saw use cache for Next, which naturally alleviates that problem, I think. It's an interesting dimension to things, probably worth exploring. In our case, only for our use server functions, but it's interesting nonetheless. So are you all, have you heard about Next use cache? I would love to kind of see if I can pull this out, because I know it's not, I think I found a tweet related to it. Let me just see if I've got my bookmarks. Here it is. It might be hard to read. It's pretty dimmed out. Hey Theo, how's it going? Came in just as I was talking about Next Cache API. Yeah. Well, it's just funny because the day you did the stream, which is when I heard about this, I was literally working on advanced cache extension, and I realized that my approach, I was like writing this article that I was just sharing. My approach just couldn't account for server caching. It just was outside of the realm of what I could solve with the solution. So I was like, okay, I'm just gonna put that aside and focus on what I can solve. And then I saw the stream and I saw this use cache, and I'm like, oh, so this solves the thing that I just put aside. Okay, seems interesting. That was fun. Yeah. It's interesting, right? Because use cache suggests that the whole concept here is that they have some kind of global config for the caches, essentially, and you can override it within that context of like what you want the behavior to be for that. But this lets you like just anywhere in I believe server run code, just put use cache. So whether it's in a server function or action or whatever, or server component, you can just like say cache this thing. And what's interesting is you could argue that this should be a runtime mechanism, but yeah, the biggest thing for me is why this API, right? Why do you use this? Because this denotes generally a compiler split. Like an example of why you would use that is if you could cache it at build time. That would be why you'd want this, because then you'd split the code out and then you'd be like, this is an entry point, and at build time, I want to cache it. Putting it here, I'm not sure actually has any compiler impact. Like beyond, like my guess is this actually just compiles into a wrapper, like a function calling a function, like a hawk, so to speak. Because watching Theo's demo, which I don't know if he's released the video yet, but it's definitely worth watching. It still always fired the first time, and then afterwards it was cached. So initially you'd see the loading from the suspense, and then any subsequent time it would be cached. Obviously you can build more interesting behaviors, SWR and whatever on top of this, which is very compelling. But the cache didn't start from build time. Well, this is what I'm looking at here, because the part of me is wondering about particularly about the use of syntax, right? Sunday and requires a sponsor. Makes sense. That's fair. Right. It's so funny because I literally was writing how I was getting away, like when I was working. Sorry, where is it here? I was basically saying that like we're gonna rename our cache API because I wanted to free up like the word cache to mean something else, and then literally like the next day, same day essentially, I see this and I'm like, okay, so is this what I'm freeing it up for? The one benefit I like of this right now is the same thing that we just talked about when I was, sorry, I gotta close this one, it's confusing me. When I was talking about this, wrappers don't work great here because let me show, where was it? Oh, right, it was my Strello demo example. Yeah, wrappers don't work great here because when you call a server function on the client or the server, that's when you go through the wrapper. But when you hit it from an API endpoint, it's only this code that gets extracted out. You don't actually hit the function, you hit the content. And the benefit of use cache is that it's on the inside like use server is. Like this means that like, you know, it's within that block scope, which is interesting. Yes, it's a wrapper, but it's a wrapper that we know actually exists from all contexts. You're saying like this block, wherever it runs, whether it's coming in through a server function, whether it's getting assigned this variable and being called, it exists. Whereas this wrapper here is not in the server function. It's like if I wanted to use cache, I would literally have like use server, use cache, like bang bang. You know what I mean? Like in the same context. On one hand, right? You have to put if you used a wrapper here, you would have to put the use server outside of the wrapper. Do you know what I mean? Like it'd have to be like async function, use server, now use cache, right? So these wrappers are insufficient here is what I'm getting at. It needs to be inside the server function. Right? Like, do I have to write it out to show what I mean? So just grab a playground here and just clear this. Let's delete everything. What I'm trying to get at is that let's just grab this example here. Doesn't really matter what this code is doing. Now, I was talking a moment ago that I'd change this to query or something, right? Not cache. But just so you can understand the difference between these mechanisms. Query, okay. So this is a query like TanStack, right? It's like wrapping and setting it to a key, right? This is different though from caching the results of this, which is this user. Now, I don't know why I'd want to cache this user. This is an auth thing. This doesn't seem like, let's forget about auth for a second, get this out of my way. What I'm getting at is, in theory, I don't know how you'd process ordering of wrappers. Like if you could, is it possible to have multiple directives in a scope block? Maybe not. Maybe this is actually what gets in our way. There's this. But if I wanted to like use a use cache wrapper here, I would have to do it right here is what I'm trying to get at. It can't go outside. It has to go inside. So it'd look like this, you know? So there is an ergonomics aspect of declaring the scope. At first I was like, oh, I don't get why I'm using block scope to manage this, because it doesn't need to be compiled. It doesn't necessarily need to be compiler if it's just doing a function wrapper. But yeah, I need to, are only one of these allowed per block? Like, I think it's interesting if you strict, like, and does order matter? Is there anything semantically in JavaScript that prepares us for this possibility? Because for us, as I said, it is all about server functions, right? That's our only interest here, essentially. Obviously, people are saying, "Oh, use server cache," right? Can you just chain these together? Like you server cache. I'm not. I think making these configurable goes against the principle of it. Well, what server isn't at the top of the file because I want this on in the client. This is a client query wrapping a server function. So I can just go here and then like you could put it in a separate file and put use server, the separate file, and then put this in a function that blocks it. But I mean, then you're going to have another place where you wrap the query to and have an additional separate thing. This is always on the outside, so this definitely doesn't belong in this category of thing. It's also configurable. It has keys. You know what I mean? Where this cache mechanism here is much. It's just it's like a memoized function. It lasts. I mean, to be fair, the reason that we have keys here is because it needs to be isomorphic across the server client boundary. If it did not need to be isomorphic across the server client boundary, but it would be a different story. But yeah. You can have, yeah, I mean, AST Explorer is probably not gonna, it's probably not gonna complain about it. It sees a string with a semicolon. I just meant semantically if there's something that gets in our way. Biggest thing is I don't think this works the way Vinci handles these directives. I think Vinci, I mean, it collects the references. I'd have to talk to Nikhil about this. Yeah. It shows as directive? Interesting. I want to see that AST Explorer. Is it? Yeah. Vinci can be updated, but it's more of like it's a much more considerable difference. Like Vinci is based on roughly how Jared was thinking how Bun should generalize it. Because right now I'm just seeing an expression statement with an identifier. If I need to give it a name. expression statement, literal. Yeah, I just see. Is this, how about Babel? Babel see it different? Aha, Babel sees it different. Gotcha. Acorn doesn't, but Babel does, and Babel's all that we care about, right? Let me see here. Interesting. So Babel, directive, literal. I see what you're talking about. That's interesting. Huh. Is it anything that follows this pattern? Yeah, okay, so they just, what if I put like var a above it? I'm just messing with it a little bit. Okay, so directives are limited to the top of the file or the scope block. Like if I do this, does it turn into a directive again? Okay, not scope block. How about function block? It does. Okay, cool. Okay. Nice. Nice. Okay, it's interesting. I don't know how you would process the ordering, because I think it's one of those things that order would matter, unfortunately. Like, I'm just thinking from like a generic tool. Yeah. But it's definitely interesting, right? Like to think that you could be like use server and then go use cache and then be like, ta-da, you know. What I like about the solution is I've been getting things where people are using Solid's cache function as essentially trying to use it like this, like putting cache functions in cache functions, which is another reason why I'm calling it query now. They're like, why can't I put my cache function in my cache function? And it throws when it handles this redirect stuff. This literally doesn't care what you pass to it. So I like it because, you know, the difference between this and this is this will always go to the server but return the same cache result, whereas the other one will only go to the server when the client has revalidated. But if you can always extract this part, right? Which is more of what people are looking for, I think. Like, because we had people trying to like wrap this in cache, which I'm renaming to query. Yeah, my first account look at this is this solves the opposite side of the problem I was solving. So I'm actually, I find it very complementary to what we're doing right now. Because in a sense, it's interesting because use cache can only have meaning where infrastructure is involved, right? Like you have to be able to say use KV or whatever, right? So it's going to be a fun one to see how they expand that for Next on non-Vercel platforms. but generally speaking, as a general mechanism in the meta framework, it seems convenient. It's kind of interesting. You'd have the error on it going to the client. This is a server only mechanism. Client can keep doing what it's always done. Okay. They actually solve this in Next. They have like an imported API, which is like cat something like I don't remember the thing, but it's like cat. You can basically import something, then it's like, use cache profile default or something. I didn't like so, and this one will error if it's not called from within a cache function or whatever. So there's like using use cache seems to disable a bunch of other options next way since they're no longer necessary. Well, exactly. This is a much cleaner separation because Next was trying to find ways to wrap like, oh, DB call, fetch, and then React was like, okay, here's this cache function, but it wasn't expandable enough. Yeah, I it's interesting to use this kind of hybrid approach of compiler plus runtime. But I think it's actually very poignant to kind of point out like why the like configurability is not something that you do through directives. That's the thing. This doesn't invalid. This is I don't think this cache. I think this cache is based completely off arguments, and then invalidation is purely time based. I don't know how this would ever keys. Yeah, compiler, runtime, plus infra. Yeah, all three. Yeah, yeah. Yeah, the not configurable makes them hard. They also can mess with TypeScript. Like you can use wrappers to fix TypeScript for you. That being said, um, I don't think the wrappers will ever be as obvious of like what their intent is. There's something about use server that just goes, you know, which I've come to like actually more over time. But yeah, I'm I actually maybe I'm gonna have to look at this. I don't know how invalidation works. I assume that this was more of like a cache that doesn't invalidate. Like you remove the cat like what are you're right, there is no cache keys here. There's like a stale time and expiry time, but I don't think this is like flush the cache kind of thing unless it's like clear the whole freaking cache. Maybe Theo knows more than I do, but there I don't remember seeing anything about a key. I'm obviously not going off the source. There was like a because see like this just gets rid of all the weird fetch like behavior. There's a tag function. Okay. Okay. Gotcha. Okay. Yeah, that's interesting. The fact that yeah, that is interesting. I like it from the perspective that it forces the block, which lets it like coincide, like combine better. But this, I mean, I'd have to see. This feels like it, like the common case requires arguments. Yeah, validate path. Yeah, yeah, no, I hear you. Yeah, it feels like I think this is the tricky part here. It's like if things that work without arguments work well here. Things that require arguments are trickier because yeah, that is an interesting one. So use server, you could argue that there is an argument get, but since the get only matters from the side making the request, like in Solid, we just do this, ta-da, get. Like it's actually relatively simple because the behavior is defined from the outside. So you don't care about this configuration when you hit the API on the server. So this is actually the perfect wrapper. You don't actually need to pass arguments to it. But with cache, if you're expected to pass arguments to it, like cache on this tag or set this cache profile for it, like if it's actually configurable and you regularly get in the course of configuring it, it's less compelling here. See, maybe the default thinking, and maybe this is where the thinking is that post to the default. But yeah, and we just literally just wrap get. To be fair, it's actually hidden on this object itself. If you actually go into this, if you grab the server function and just call like .get on it, it'll also do it directly. We just have the wrapper to pull it out easier in terms of this question. But yeah, post is the default. But my arguments against this would you make helper functions with tags yeah, it's just the argument. It's so much cleaner not to. See, the only argument that I can see that I would really want this is if our belief is most people aren't going to be setting keys. Like that they're non-revalidatable cache. If the common use case is non-revalidatable, I am okay that on the edge case, you come in and you're just like, cache, key, hey, yeah. Okay. I can live with that. Okay. I got a better idea. Huh. Yeah. Why don't you just do this? We just do the same thing that we do already with all this other stuff, right? Solid's query function. When you do this, get user for us, there's a key for, and you like, let's pretend this had, this took a number as an ID or something, right? We have key for 3. So you can like you can call it without calling it, and then this will return like user 3 or something, right? Like, and in the same way I was saying before that our actual server function, like in Solid, when we do this, when we do this, essentially, let me just go const d or something, whatever. We can go d.get and like it'll do the get request instead of the post request, right? It's kind of built in. What stops this from being essentially like get key on this, or just like heya.key, and then revalidate tag heya.key? Do you know what I mean? Like, what stops us from actually, I mean, we don't even need this. What stops us from just doing this? like we don't have to go over a freaking network boundary here. This isn't the thing. I don't think there's anything that actually stops us from passing inside like a server action or something, passing the reference to the function and telling it that it needs to revalidate or something. I don't know. I'm just trying to think of like, or it's not even revalidate. It's actually invalidate, because you're not fetching it again unless you are fetching it again. Oh, right. Right. Well, I mean, if it works like TanStack, like the way we do, it's a starts with query. So this will this would invalidate, right? Heya takes greeting that's a string. Okay. This invalidates all the greetings. This invalidates actually we want TypeScript to work. See? See, what I'm suggesting here is that the function identity is the key. And because we don't have to worry about serializing over boundaries or freaking, I don't think we need to. I have to double check that, but because we don't have to worry about serializing over boundaries, and like minification and stuff, I think that this would work. TS doesn't. TS doesn't. The same way TS doesn't know about the stuff I did on thing. This is why I had to expose freaking. This is the whole reason why get D exists. So like as a no, like if TypeScript always pisses me off, it's fine. You could do this. I think. I'm pretty sure you could do this. There you go. And in fact, I think you could do this. So maybe this is the correct answer, because you already have to pass into a function. Maybe this is maybe this is the correct answer. Yeah, you got there faster than I did. Internally, for this to work mechanically, we'd be putting stuff on the Heya object, like on the wrapper, but essentially you could do this. So yeah, this is attractive because now I don't need keys. Yeah, that's now if I don't need keys, then setting the cache profile is the only thing I need to customize. And if you set a reasonable default, it's going to be the exception case. You can just use cache wherever the hell you want. And yeah, okay, we're good. There we go. We have solved the use cache thing. No keys are necessary. You don't need revalidate tag. You just pass in the function reference. Technically, you'll have a key on it, but TypeScript will be happier with you if you just do this. Yes. Yes. Yeah, no, yeah, no, yeah, it's quite possible. It's you play around with these for a minute and then you like think, you're like, okay, yeah, this is how it has to work. As I said, I'm sure they'll come to pretty much the same conclusion. Yeah, no, that's fair enough. I think it's just like a Lee Rob video and like a write-up somewhere. Anyway, I mean, technically we could also do, but the TypeScript for, like, we don't get types for hey because of the way the wrapper works. Yes, this is just a server cache. I mean, yeah, I think this, I mean, now you're going to be thinking like, what would it look like from the client side? That's an interesting question, because assuming that you do the same thing where you set the profile on the client of how you want the cache behavior to work, client has reactivity, which is kind of a pain in the ass here. You could have a life on a memoized function though, and use the same mechanism. Yeah, I don't know. Yeah, I see where your head's going here. The challenge, right? Because then the configuration, like the router would just provide a cache configuration. The problem with the router is it needs to be isomorphic. So we need the key. The reason we got rid of the key was because we didn't need to be isomorphic. Like if on either side you can use something, we can use the reference identity, but if you have to serialize this, you don't get to do that. Yeah, to be fair, our invalidation works similar with the composite keys. It's just the thing is like, yeah, I on the client, yeah, because you can always set a custom key where this, I mean, you could have overrides for setting a custom key. I'm just playing through it all. It's interesting because my, it's tricky because how do you indicate that you want the cache? Okay, I got one for you, Dev. How do you indicate you want the cache on the server and on the client? Like, what I'm getting at is what if this is here? Is this a server cache or a client cache or both or whatnot? It's ambiguous what the intention is here. Yeah. The compiler can add the fake function, but TypeScript will never know that it's there. Like we add the fake function with what we do, like that, like our get on server functions is like that. We literally have like server function and then we do like d.get. This exists, but TypeScript will never be able to know because TypeScript just sees an async function. You have to wrap it so that TypeScript, like this goes like, yeah. You got to wrap it basically, unfortunately. This, yeah, I mean, if you're going to come up with custom rules looking for certain things, I think you can do something probably. I mean, these align pretty closely. Yeah, not cached. The server only because it's in a server function, right? But like what I'm getting at is this might actually be pretty common. Like we need the potential to be able to serve both, I think. And it's tricky because you need it to be a wrapper like this directly. Yeah, I don't know how to express this otherwise without it being inside, because you need it to be a wrapper directly. Because I don't know if you know this, but if you do this, like this is no longer a server action in Solid, because it like if I called this, do you know what I mean? Like, because it's not passing the server function directly in. There's arbitrary JavaScript code that could run here. It will run this on the server, but there's the potential that it needs to hydrate or it needs JavaScript in order to run. So it won't work with progressive enhancement. Just like trying to think of like how you would write the equivalent of this, where you have caching on both sides. Yeah, I think this is where we're landing here. Yeah, that's my gut. It's fine. We could think about this further. But yeah, it's interesting. It's definitely interesting. The fact that this isn't isomorphic, meaning that you don't need the keys, that you can do this kind of thing, I think makes it. It's the thing that pushes it over, because. Yeah. Yeah, no, I think I think a lot of times what you're gonna do when you build your app is you're gonna set a default cache profile, and it's gonna work for 80-90% of your stuff. You're just gonna drop use cache where you need it, automatically work, fire in, put these next to where, like in our action, where we go revalidate this from the client, invalidate these, server caches. You just put them right in your actions, same kind of place, and then you're just good to go. And then in those like couple places where you have that like highly sensitive data or thing that you never care about, you just set a custom profile, call it a day too. But 80-90%, you just use this and you're done, which is DX-wise very attractive. Okay. Okay, cool. Dev's like practically on the plane, and I don't know if I'm gonna. I have my last thing to go to. Where is it? Server signals as architecture. Okay, see, look, I even mentioned Dev right here. I don't bundling gotchas. I don't know if there are. The big thing is I don't think there is any bundling consideration with this. Like, I don't think it actually breaks things apart. I think it literally just puts a wrapper on it and calls it a day. Like, I don't think there's actually any bundling. You don't code split on the cache boundaries. You literally just go, that's why I was kind of saying, like, this isn't necessary. It's a programmatic, it's just literally just programmatic code wrapper. You can validate a server cache key. No, it has to be called from a server function. It makes sense. So if you're on the client and you go and you want to invalidate a cache from the server, like you have to basically do a server action, and in that server action, then tell the server to invalidate the thing. Otherwise, like the clients, yeah, no, it's you got to do it from the server. Confirm it's just wrapping with programmatic IDs. Yeah, exactly. I'll get Wi-Fi. Okay. Yeah. Well, I mean, it makes sense because the function only exists on the server. So like if you import in the client, I'm gathering it would just error, which means that like it only exists on the server. So the only way you can actually get to it is by calling something on the server. Okay. Dev's been doing some pretty great work with signals in real time. He's been prototyping, picking up every not ready Solid 2.0 API. He's like been asking me about these APIs and literally using Solid 2.0 reactivity before it's ready. But he showed me, he made a post. Where is it? Here, it should be in my bookmarks. About signals. Signals are so well designed for the problem they intend to solve that they end up not being the best choice for other problems. Which is a fair observation. But basically, he was saying that like because signals need something to subscribe to, like they're like event streams, right? They're sorry, they're not event streams. Like signals need to actually have something read from it to do the work. So if you want to like be pushing events from like a WebSocket, they're not the right fit. You have to like fake a sync even if no one's listening to it. The problem with signals is like they only care if someone's listening, so they only do the work if someone's listening. So it's not like what ends up happening is if there's other work that has to happen because of that and no one's listening. When you start listening, you suddenly like then go fetch, then go do the thing, which isn't really productive here. Generally with WebSockets, I'm gathering all these architecture, you want to just keep on pushing the updates and have them available, and then even if you're not reading from them. So Dev was working on some like interesting approaches to this and asking about perspective on this. And I mean, obviously there's ways to solve this with signals, but we got to a point in the conversation where I was just like, what are you even building? Like, I don't mean like I've seen all the demos. I'm just like, what is your use case? Like, why are you, what are you doing? And I mean, I think we have this because he's going signals lazy, pull based work fantastic in synchronous context, but async lazy signals. Yeah. And the thing is, create async is going to be eager in Solid 2.0. It's going to fetch immediately. It's not going to wait because we need to avoid the diamond problem. Similar problem when you have throwing, like you can basically, if you wait to when you pull and you have it throw, so like the first async thing throws, then you don't get to fetch the second. It doesn't make sense. We need it to be eager. But even with that, things that are never listened to are still lazy in that sense. So in any case, I was thinking about, I'm like, okay, what are we doing here? Why are we using these? Why are we using signals on the server? And if a signal fires in the woods and there's no one around to watch it, yeah, no work gets done. I realized yesterday that you and I have slightly difficult service ends. I just want to share state between clients. You want to rethink hydration. Well, I mean, if your goal is just to share state between clients, then you just have a WebSocket, right? Like you don't need signals for that, right? Right? Like the client can be the synchronous part with the signals, and the source can just be whatever the message. I guess it could be an interesting message protocol. I'm just not sure what the signals on the server are doing for you over any kind of other event bus, right? But then I was like, okay, why would I want signals on the server? Well, what if I want live view? So we talked about this earlier about app architecture. And so my question was like, I asked myself, and I'm like, can signals make live view better? Can we make a better live view? That's sort of where I started thinking, because I was like, it's not, hydration came in, but that's not why I was doing this. I was just like, signals themselves as a mechanism to communicate might have some benefits, but once you leave the synchronous zone, it doesn't really matter. You can have signals on the server, signals on the client, have them do their own system in sync, and then they can just push out events across the boundary and handle each other's separate systems. You know, linking it or trying to fake the linking of it is, it doesn't, like they aren't async to begin with, so it doesn't make sense. Right. So there's a DX consideration, right? Potentially, but so there is that consideration. But I was like, okay, well, what? But there's a comparisons to things like live view. I saw some work with the Preact guys in Fresh, and I was like, what can we do here? Could you make a server signal create? Yeah, but my question for everyone who's doing this stuff is like, what is the signal on the server doing? Where is it living? Like, otherwise you're just calling set state, which could be message.push or observable.next. Do you know what I mean? Like, what is the signal graph doing for you on the server? What is it synchronizing? It's not rendering UI, presumably. Like, what is it doing? This is where I'm very foggy, because there's got to be an impact to the graph or the connection for this to be any different than any kind of event bus. Right, multiplayer apps, but what is it actually doing on the server? I understand on the client that you're like, hey, I've updated this value, send it over here. Right? Yeah. Like, I am missing a huge gap here because I don't understand what the signals are doing on the server at all. The one thing I can picture signals doing on the server is render. So that's where I started looking here, because as we talked about earlier in the stream, there are arguably only 3 architectures. Signals live here. Signals live here. They're great in Astro. Solid plus Astro is amazing. Signals don't live here yet. And can we use signals to make this better? It's a graph that connects many users. Yeah, but are the nodes all in the client? Like, is the graph still on the other side? I guess the yeah. And like, if they're like, I've seen stuff like Convex do this kind of thing, but I've also been perfectly fine with Convex taking that path all the way straight to the client, or Sync Engine, same thing, taking it all the way straight to the client and then shoot out from the client side. So anyways, I started thinking about, well, can we mechanically use signal like in stateful servers, right? So when we talk about UIs, we generally talk state down to DOM, right? We function as UI of state. We focus on the get, like the render. But to talk about this topic, we need to trace back from the post. We need to go all the way back to the event source. Instead of thinking of our application starting from what we render, we need to think about it starting from what we interact with, what we click. This is something that possibly happens on the client, that always happens on the client. So if we want to have the server involved in the process, it starts with understanding where and how we do the handoff. So basically, with live view, you render a page and set up your live view, your WebSocket, and then from that baseline, like the server's already done the rendering. So from that baseline, you click something, you interact with the page, and that is the entry point. And if you think about it, Quick's resumability is also like that. They don't hydrate, and then everything happens from the event delegation. That's when they load the code. Except Quick does all the work in the client always, right? Because it's a single page app mentality. You click with something, then you need to bring in the JavaScript for the click handler, set the state. That triggers other JavaScript, load, run that JavaScript. But the thing this has in common that I started realizing is it assumes that the server's already put you in where you need to be, and it starts from the interaction point instead of starting from render. Almost all UI frameworks, basically, we talk like rendering. We're like, oh, React renders, create that DOM. But if you start from a position where rendering is not the top of the tree, the top of the graph, but the interactions at the top of the graph, it changes your perspective here, right? So the easiest way, I'm actually using the live view example here, is event to triggering the server, right? I mean, even higher level, I guess you could say, is if you literally just captured the click event and then serialized that straight across and then like had it bubble on the like a DOM on the server, that would be even further. But I think live view just basically turns events into RPC calls. Like it is, don't get me wrong, I know it's a WebSocket. I'm just saying it's a named event. So like a named function that you're saying, do the decrement, do the increment, right? So, inside your live view, this is live view.js, for example, you can see what it is, update your state, and then have it render on the server and send back the diff, right? This is how live view works. It's the most basic thing. A couple things here is it probably handles stuff at a component level. Do you know what I mean? Like you set the state, it re-renders the live view, or it calculates the diff, but it's not using signals here. So there's no granularity in terms of how state updates. It literally goes, okay, I need to recalculate my thing, do the diff, and figure out what I need to send across the wire. So maybe that's the first potential where we could do better, maybe, right? My first thought is to have the event always execute. Okay, yeah, so actually that's not where I actually first thought go here. My first thought actually is to have the event always execute on the client. And actually, you know what? I'll save this. Put this in the chat so you guys can see this. Okay, so originally it was route level. I think they have a component handler. Yeah, I started thinking like, what can we do better, right? Right, the real one. Fair enough. So I was like, first problem that we saw when we were doing our architecture is that it's hard to do the client-side stuff. It's a separate model. So I was like, what if we have the events always execute on the client and be interceptable with JS code? So I'm thinking kind of like Quick, where the event handler is the island. It's funny that I said like Quick, but I use the term island, but that's what I want you to think. Think of the event handlers as the JS islands on a server rendered page, not the based on render code, but the event handler is the island. And picture in that event handler, you could basically set signals, right? But that closure of over the signal setter or read could be something that could be serialized. This is why I started thinking like Quick. Would there be any benefit to this, right? To being able to like run arbitrary JavaScript code in the client and have it trigger signals essentially that would then update on the server, re-render parts of the app, only specific parts on the server, and then send back the diff and update from the server, right? So I'm just kind of thinking kind of live view, except instead of the events being the transport, it's signals. Would there be any benefit to this? But only if you could also do client-only things, right? Like you're in the event handler, why bring that to the client unless if you're just going to go to the server directly anyways? So I think you start going, maybe we need server and client signals. So picture if you had an event and you could like basically have two different types of signals. This is just hypothetical. Then you could set off a chain of events that only happen in the browser declaratively, and a chain of events that only happens on the server as well declaratively, like a shared universal model. Okay, does that work? Right, you could like change the selected state, which could directly update part of the DOM, but switching a visibility of a toggle could go to the server and render the whole new section. But there are two challenges to this. First of all, how do you render something on the server when there is state only the client knows about? And how do you isolate it from the client side to know it's responsible for render? We end up in a use client land, I think. You end up basically with something that's server component, like saying like this is part that's client responsible. That's too muddled for where I want to go. So let's consider alternatives, right? Basically, I understand we could have like traditional solid, say, like reactive signals as like blocks in this model. So you could basically have server components that do signal-based updates and then have interactive things that do client-based updates. But I want to do more pure. So I want to live in a world where use client doesn't exist. So let's not go there right away. What if all signal writes trigger propagation on the client and server? If the execution never makes it to the server, a server-based derivation, then we know that the server doesn't have to respond with anything as the client can handle it all. So an example of this is if you updated a value and it literally went straight to a CSS class from like the propagation. Like all the effect is just render this new class. It doesn't need to go to the server. So the question is, how do you make this classification of what is a server derivation? It starts with the premise that all new element render only happens on the server, okay? Let's pretend that JSX only exists on the server. This isn't a solution for optimistic updates, like, you know, that might be use client. We'll get there later. But anything that would lead to rendering new JSX would be on the server. So like a for component or a show, any place where you actually have a conditional that would cause structural changes would always go to the server. Anything with async data fetching, always go to the server. So in this world, the reactivity graph would need to be completely serializable, and both sides would have stable IDs. Then reactivity could synchronously propagate on the client as far as it could until it hit an async derivation, right? On the client, these scheduled syncs, just like effects, they're scheduled basically, just like effects. So we can send them all batched together. So if you do an update and it hits a bunch of server stuff, you can just basically send all the stuff on a single go across, you know, these web sockets or whatever. And we'd serialize up that part of the graph and send a request to the server to update its values to continue the rest of the propagation. So yeah, basically effects that directly render the DOM could live on the client, and anything that would actually, like, by render the DOM, I mean update values, like attribute setting, like, I mean, this distinction is actually very noticeable. I'm going to delete this for now. In Solid, you can actually see the difference between, say, an insert and when I go, let's think something. Let's go title equals, it could be class here, but let's make it count just for fun. You can actually see that this is a different class of update than this is. I'm saying like something like this. I mean, this is the worst case scenario where it's text being directly put in, would go to the server, where something like this could actually stay completely in the client if we wanted to. There might be better heuristics to identify this case so that you could tell that this is just a value and not JSX, and then it could also stay in the client. Because like if like, this is silly right now, but if in Solid, if I change this to text content equals count, what you'll see is that it won't do an insert. It will actually know to essentially set the text on the data node. Just an aside, this is completely hypothetical, but I just wanted to kind of put it out there that in this kind of world, it's possible that things that update existing DOM could never need to go to the server, like updating classes, and things that required structural changes like rendering new elements could go to the server. It wouldn't be an increased payload, but it might be fine because on any given change, you're not going to end up serializing the whole graph, only parts of it. And then the server gets the updated graph, and then it finishes the propagation and sends its values back. So this game, again, it's kind of funny. It's like ASP.NET, which is a terrible thing, to be fair. But in back in the day, we used to serialize up stuff, do part of the work on the server to the client, and do this handoff back and forth. My question is there a world where this handoff, if it were fine-grained, could be efficient enough that we don't have the old like giant view state problem? The problem with ASP.NET is you'd send all the freaking data and then send all the data back. But what if we could split it up to only the parts of the graph that actually updated? Then we could actually get past that old wall. And see, and an interesting side effect of thinking about this is maybe all effects would live only in the client, right? This is how you know if you can propagate all the way down to the effect, then you know you don't need to go down to the server. Okay. And I started thinking about compilation, and this is why I got to doing it, because I this doesn't matter a ton. I was basically, the code that I generated here is my proposal is identical to the code that I generated for resumability, except it's even less. I realized that in this thing, it's very similar of like doing this kind of scope read thing. Don't worry too much about it. If you haven't read my resumability without serialization idea, this probably isn't that important. But what I realized is that we could basically do something similar to Quick's compilation, but because we're assuming that all the rendering's happening on the server, it could be even smaller on the server. Basically, the thought is that all signals are basically isomorphic or server only. There's no client only signal in this kind of mentality. So the reason it's isomorphic is we would render the signal originally on the server and write it to some kind of scope that could be then registered and read essentially from these scopes. So you can grab the DOM node, grab the signal, and like node insert it, or do this and do this. If you knew, like in this case, I actually show it all happening on the client. Once you register these events, this reads from a single and increments the value. It could propagate through, because this would have been set up as like basically because you serialize the graph at initial render and have all the dependencies, you have this living memory version of the signals in the serialized data, and then essentially you just have to inject the scope on these event handlers, essentially. So it's like it's hard for me to explain this to anyone, but this is the way Quick, Marco, Wiz essentially work. And technically, it's kind of basically like Quick but smaller. Yeah, don't get me wrong. I think there is a potential that the server signals would have to have some kind of effect. I just meant from like a rendering standpoint. Maybe the server would need like its own category. There's like use effect and use render effect, which are very clearly client, and then there could be like use server effect or something, right? There is probably a use case for writing out on the server side. I just, for the sake of the case of rendering, which is what I'm focused on, I was just like, let's just pretend that these kind of effects are client only. This is hashes from the build. Basically, this component can only ever run on the server and will never rerun. Like essentially, we run this once on the server, serialize stuff, and the only thing that we end up doing is registering effects and events, right? There's no the client code does not include the ability to actually re-render this component, which is fine because we registered the events in that. It still has the ability to fine-grained update just the count of this text node without going to the server, because it registered the events, but it is incapable of actually rendering it. And while this looks like it's large, this would min zip down to nothing. And like, yeah, this is super small optimal code. So what if you need to do something, like maybe show when, like some kind of toggle, right? I kind of made this too, but the idea is like the expression from this show would be a server. Like if show returns create memo in Solid, it could be like a server memo. So essentially the client only needs to know that it's reading from the scope and create the reactive dependency. It doesn't actually need any of the code to actually do the rendering. Yeah, let me see. How did I do this? The signal will trigger internal memory by show, which would be marked as server only. This would grab the children, also part of the server reactive graph, and render them the value showing to it, right? Because I'm saying that this actually is only on the server as well. Yeah. There's gaps in what I'm explaining. I put a div in here to make this more visible. Like if there was no top level div, it's an interesting exercise of figuring out how the components compose in order to continue to do this. But it's so similar to what we solved for resumability that I'm pretty confident that something like this could work, right? Obviously, I haven't talked about server events, which is, it's possible that a database triggers stuff like live view style and pushes it through, not live view, sorry, like, like when you have like real-time database updates, kind of polling, triggering all the UIs. Nothing here, I think, stops that from working because it's all connected. It just propagates it back along the socket. Optimistic updates, I don't know. It suggests a need for client islands. But I started kind of thinking, if this, would there be benefits of this kind of architecture? Yes. Yeah, the server memo does run when the show condition changes, yeah. All right. This is where web components shine. What? Web components don't do anything. Web components would actually probably completely get in the way of this. Okay, anyways, let's move on. So let's make sense. The double data serialization is caused by the need to client render. We use things like islands as a way of isolating that, but client routing basically reverses our decision. One approach is to try reverse data out of the HTML, but the other might be to recognize that not all interactivity needs to involve client rendering. If the data clearly is on the server, then maybe there's a zone where we can know to skip it. That's been the problem. We don't know from an API standpoint. I'm not sure this gets us there either, but if there's potential. But if we turn the whole conversation to be about serializing the reactive graph, maybe there are some rules that can emerge. So just kind of off the top of my head here, signals are isomorphic and can live on both sides and triggered by either, sure. Effects are generally client only, but maybe the left side isn't, like the tracking side, in terms of split effects that I've been talking about. We need to know what to pull on both sides. Derived values can either be isomorphic or server only. Signals whose setter is never called from the client could be considered a server node. So this is where I'm start going. Like, there's a heuristic here, right? Like, you could basically say that a signal who never gets updated doesn't really need to go to the client unless something that's derived from it also depends on something from the client. So you start kind of coloring the nodes. Derived values that only read from server nodes don't need their sources serialized and could be considered server nodes, and so on. It is only the intersection of server and isomorphic nodes that require the server side of the graph to be serialized, which is interesting because, like resumability, this sort of automatic optimization will lead to significant behavior changes over very subtle differences. So it's tricky. What custom elements have no bearing on what I'm talking about here, as far as I can see. It's custom element life cycles actually probably get in the way of this being hyper granular, right? Like, I'm talking about code entry point literally being a specific entry. You don't want the rest of the DOM life cycles. You don't want connected callbacks. You don't want, sorry, you're right. I'm getting hijacked. Okay. So let's think of a couple examples here. The first example, my favorite, solid. Let me pick what Solid Hacker News. What was it? I can never remember. I have like my experimental app, but that's not the one I wanted to open. But it's fine. I'll just open this one. Let's consider this case. Where I'm getting at here is, yeah, like the comment toggle would be completely isolated from the data that renders it, right? If you've ever seen the code for this, see, do I have Solid Start open here? Strello, I have Strello open. Okay, no, it's Solid Start. If you ever seen the code to render, let's say Solid Hacker News GitHub. Let me just. I don't know if I actually changed. I can tell in 2 seconds. If this one might not have the, yeah, this one doesn't. Just go to Solid Start. Let me see. Okay, Solid Start. Examples. Hacker News. Source. Components. Okay. If you've ever seen this toggle component, this is separated because it was for islands. The logic for the state of the toggle is completely independent. Like, you don't see the data here that like is rendering in the list. It just gets passed through as props.children. Each one wraps, but the actual content is in the comment component, and the comment component just gets wrapped by this toggle. So it projects through, essentially. because there's no connectivity in this kind of use case, then there's no need to go to the server for the server to serialize the data, because it could basically tell from this that the async source never intersects with a client source. There's a wrapper there in the view, but they never intersect, so you don't have to serialize it. And the only thing that actually gets set in the view is, well, we can see it right here in the toggle, is on click set open right here, which means that this would need to be serialized, but the main content of the page. So in a sense, like resumability, resumability comes back when you add client routing. But generally speaking, we know that because we know, like in an MPA kind of setup, or resumability when you use it with an MPA, that we're never going to client render the page. We know that it's safe, that we don't actually need this other data because there's no intersection of data. So the funny thing about this example, though, is right now, this toggle open sets a class. And if we're just setting a class, this can be done completely on the client. If this was a show component and it was hiding the component, this architecture would actually go back to the server and re-render those specific comments back and forth, which is funny because with server components, you always serialize up front. You know the props, so you would never go back to the server. You'd render all the comments out front, even the hidden ones, and then you just toggle. This approach, if you actually were not sending all the information up front, it would toggle and actually go back to the server. But with a class list, it could stay client side. The reason I'm showing this distinction is it's important to understand that this mechanism can both accomplish client-only interaction natively through declarative, unlike live view, and also do what live view would typically do, which would be, that. Don't get me wrong, live view has a way to set classes without going to the server. I'm saying it's not part of the declarative data model. So this scales, which is the difference on the client. And another thing, consider a scenario where we're using client to format some server data, say a join date on a user profile. If it is changing the data format that appears in the text node, so let's pretend you just want to change the date format. That means the user would need to be serialized because it's an intersection between the user's data, like when they joined, and a toggle signal on the client that says change date format. Right, so we need to serialize the user at that point because we're morphing its data on the client. So there's an intersection. If the change instead was to change the visible arrangement of the profile, then it would go back to the server to render the new profile. It might not end up serializing the user in this case because the intersection point wouldn't be here. It would be something that would need to render it. I'm 50-50 right now on if in all cases this would be the case. I use both these examples because they're around ephemeral state that isn't persisted in the database. In cases where it would be persisted, which is pretty common, then it would likely be you doing something more like an action where you trigger async data refetching rather than setting the signal with a value, which means we know that it was always on the server anyways. Optimistic updates are probably the best example I can think where server-derived values meet ephemeral client state. In those cases, I don't think you could ever save on serialization because you need to have the list to think of the Trello board. If you showing the Trello board and you're showing the optimistic updates, you need the data in the client in order to know where to inject it, right? From a stateful standpoint. Obviously, you can do a manual DOM upgrade, but I'm trying to avoid the live use solution. It's not sufficient from a declarative standpoint. So I do think serialization is necessary in parts of the UI where you are doing actual work on this data ephemerally. Just a side note. But what's interesting is I think this could work automatically. Okay, could this be an improvement over diffing over the wire? I guess back to the original question, does this actually potentially do something better than, say, live view? There's a lot of complexity here. I think the most interesting prospect isn't that the potential to do finer-grained updates, but that certain updates could stay on the client automatically. The JS output would be slightly larger, and the serialization potentially, but maybe there's a path which blends the benefit of a single model between client and server, not two side by side, but the same model. It's an interesting areas that LiveView find difficult are still tricky here, but it seems like it could be much better at bridging the gap. That being said, it does suffer from serialization boundary concerns like quick, except it's only the event and the effects that are special. I think that alone might lower the friction. Security might be a concern too if serialization is so granular. The key to this really comes down to the understanding what can be determined at compile time and not. You want to color the graph, so to speak. If that can lead to savings and still allow the events in the browser, then you have makings for a unified model. Of course, you need to persistent server WebSocket connection too, so that would need to be a pretty specific architecture. But I can see a world where this is where things could go. Anyways, sorry, just a brain dump. But this is I could see a world where we took something that was similar, as I said, to Quick's compilation and isolation and applied it to a stateful server world to actually get the benefits of Quick and never send the stuff to the client. I think that's one of that will solve the double data, double HTML problem. It could actually solve the whole thing. It's also freaking complicated. You basically have to do all the work that's required for something like Quick. Plus, yeah, I mean, this is probably the most ambitious, crazy idea I could think of. So now it's out there in the ether. People can think about that. I don't get why people are talking about web components here. It's almost like when people were like, oh yeah, web components, it's like web components are barely passable as islands. Like, and we're talking about stuff that's like, it's interesting. If you use the fact that they're an encoding for DOM elements, I guess that's interesting. But the fact that they require JS is awkward. It feels like you could create your own custom encoding onto DOM elements, script tags, templating, comment nodes, and you just be more efficient and require less JavaScript. So it's like very confusing how you guys have web components be like anything. Yeah, you know, about the potential here. Yeah, you've already implemented it with web components. Yeah, that's the solution. Funny. This is sort of Marco 6 thing. Yeah, I mean, this is, I mean, Marco 6 and Quick are in this kind of zone. Marco 6 was basically, you can view it almost as like Quick, but fixing the awkwardness around the DX. They wanted to use the compiler just a bit further so that like $ weren't necessary anymore. That's like Marco in a nutshell. Like, what if we can solve the same thing similar to Quick, but without the $? The problem is once you add back client-side routing, it's not solved. You know, none of this actually solves for client-side routing. And the only way I can, when I saw LiveView and I think about the only way you can really solve for client-side routing in these scenarios is know 100% that you're never going to render the thing on the client again, which, you know, gets you into server component land. But the problem is sure, you can isolate the server components as being server only, whatever. But then the client components, you actually don't want to ship all of their code either, which makes it really weird to have this arbitrary distinction because they're not client components anymore. They're like mostly server components. So you have server components and mostly server components. It's a very weird split, and it's very particular. So I mean, this is a very difficult problem. So it's like one of those things where it's like Quick really wants to automate it so you don't have to think about it, which I think is a really admirable goal, but they can't solve this problem, I don't think. Funnily enough, Stateful Server, I actually think, does solve the other half of the equation. So in theory, if you put the two pieces together, you probably could have client routing plus resumable, whatever, minimal code, and never take the hit. Again, I don't know. Stateful servers might just be too prohibitive from a cost perspective. It's just, I hadn't thought along this lines, and I think it's important to explore the potential, or at least think about the potential of where we can do better. Because sometimes the compromises work. Sometimes the compromises don't really work, right? So like, yeah. Anyway, just food for thought. Okay, let's yeah, it is very complicated. Yeah. It's the reason web components trigger me is that like they often are fine but have absolutely no bearing on any solution there. It's like it's like one of those things where you're like, you can do something, or you can do that something also with web components. And the benefit of web components is like, oh, this is packaged up. It's isolatable. You know, you can. But the actual mechanism is never determined by the web components themselves, except for unless it's like a very specific thing they only provide, like Shadow DOM providing style isolation. So it's very odd when people are like, oh yeah, web components, and you're like, it's like, oh yeah, I rewrote my app in web components way faster than React. It's like, the web components didn't make it faster than React. You know what I mean? Like it literally says nothing. So I think like it's almost like, you know, I got a bit of a BS meter, so to speak, or like I don't like marketing a lot because it's like inaccurate. I think web components trigger the BS meter on me like repeatedly. Like it's so hard when you see people like say stuff about web components and you're just like the argument isn't even there. It's just like, how do you deal with so much, you know, illogical thinking? It's hard. Anyway, sorry, Deb. Okay, so to take service nodes to its logical stream, I'll have to build quick-like compiler. I mean, I don't know. I just want to know if there's something like in the live view spectrum of things, because no one's still shown me what the signals are doing on the server. I'm just like missing something there. And the only thing I can think of is solve problems that I've actually faced, which is around rendering, hydration, you know, serialization. It occurred to me after seeing live view that they don't need to hydrate, which is amazing. And they don't need the double data, and they have client-side routing. Literally nothing else has done that. There's not a single other architecture that has actually hit the trifecta. The cost is extreme, though. Right? And they have other things that we take for granted that they don't do as well. But in terms of the problem we've been trying to solve for like the last like 6 years, longer, 10 years almost, it's the only solution that I've seen so far that actually checks all, like hits all of it. Well, that's the whole thing. Like setting, if it's something happens synchronously, like it's like it comes through a flow, then you can collect it the same way we do batching of effects. But yes, if there's async going on here, this is why signals don't suit going over the wire, so to speak, right? The async is outside the system and then it gets consolidated coming in. Async setters is like, async getters is something that, you know, I've considered. Async setters is a whole other concern or problem that's way out of the scope. Yes, vanilla.js is faster than React. That is pretty much the conclusion you can come to. The thing is, is vanilla.js as manageable as React? Do you know what I mean? Like coordinatable, how does it scale? Well, I mean, you'd probably use a framework, maybe use something like Lit, and then is Lit faster than React? And you could also probably say yes. But the question then is Lit faster than Solid? And you could probably say no. Like that's what the question is. It's not web components, it's whether Lit is faster than Solid or slower than or faster than React or whatever. Do you know what I mean? I want an MPA with sprinkling islands of JavaScript. Yeah. The question, if go, I think Astro is amazing and people should just go use it all day long. The question is, I started this, I'm building apps. I'm thinking about apps. What if you could build an app, typical way, almost like the way you build with React today, and the output was essentially your MPA with client-side routing with Sprinkle.js. You didn't have to use client or say this is the client component to do that. You just write the freaking app, and what you get is exactly that. That's what we're getting to with this stuff. We literally build these crazy frameworks so we can output jQuery. Like, I mean, now that jQuery is built into the browser, that is. I don't think so. I think statefulness of the server is the key fundamental separating point. I don't think there's any similarity between these two. Statefulness of the server is like a non-start. Vercel sells serverless. Like, yeah, I don't know. The problem is like, it's why I'm talking about this, right? Once you add client-side routing to Quick, for example, then it takes the huge hit, right? We all do. This is why this is interesting. There is a solution that can solve this. Quick otherwise is basically the same as every other single page app framework other than it hydrates a little bit faster, right? Stateful serverless should be a thing, yeah. If it's cost, like, yeah. Yeah, yes, exactly. Okay, let's get to this week in JavaScript. I'm going to throw up my head for a minute, and then we're going to switch gears. All right. Thank you all for still being here. It's been a stream. All right. All right, just getting everything set up. Just give me 2 seconds. Holy shit, I'm gonna bookmark that, sorry. That's a big win. I'm actually gonna retweet this. Sorry, I didn't see that. Give me 2 seconds. I'll do that after the stream, but okay. So go to my profile. Okay, let's get this going. And then the last one I need is solid. All right. Okay. When was our last stream? Oh, wow. It was September 26th. Was it? No, that's when I wrote the article. I've streamed since then. It was October 9th. It's only a week ago, roughly. Not 9th, 11th. Yeah, there we go. Okay. Yeah. Okay. Yeah, there's not much on my personal. Let's go back. October 11th. All right. Okay. And October 11th. Yeah. Yeah, sorry. I just had a funny thought when I was looking at this because I didn't finish my thought on the web component stuff completely. But you know how there's that thing where people are like, let's add signals. That will make things faster, right? And I always go, adding signals won't make things faster. It's the things you can remove when you add signals that make it faster. The funniest thing about web components is like adding web components also doesn't make things faster, right, in itself. It's, you could argue, you know, that the thing it removes potentially is what makes it faster. But the funny thing about web components is also removing web components will always make something faster. So like it's kind of funny thing. Like, yeah, I don't know. Maybe that thought needs a little bit more pointing out, but yeah, it's a removing React that made it faster, but and web components help you get there. But also now that you're done, removing web components will also be even better. So it's like it's kind of a funny thing. All right. All right. Let's switch over to the views. Bam. Okay. I think we already talked about this. We talked about this. Okay, sorry. We talked about this. It's been a slow week. Okay, sweet. So, yeah, we talked about use cache. Talked about, yeah, we talked about all this stuff. Okay, so, all right. Okay, let's go with this week in JavaScript. It's my closest thing for a marker for Jesse gets around to doing the timestamps, which I'm incredibly thankful for. You should all give thanks to Jesse for the timestamps. They're amazing. But yeah, most of the stuff I want to talk about today is actually, we talked about the other stuff. I want to talk mostly about solid stuff. Yeah, it's going to be, yeah, famous last words, definitely. Yes, definitely. First of all, my BeatConf talk is up. Talks all about serialization. Talks about the work we did with mostly Alexis. I say we, but the collective we. But Alexis did on serialization for Solid and Solid Start with Cerevel. How serialization is a key, which you know you can see from the conversation we we're talking about to the future. Yeah, it was an interesting talk. It was a lot of fun. We've already mentioned it once before, but SolidHack is in full flight right now. Important shout out because we've been doing these how should I put it, bounties, I guess the best way to put it, and they can be claimed by anyone. Every Monday we check and see if they've come in, and we actually have our first two winners. Brenley wrote a tutorial, which useful one, basically how to do auth with clerk in Solid Start. So this could be interesting. People want to understand how to do auth in Solid Start. This is a concrete example using clerk in the clerk API. So very cool. These kind of how-to guides are so valuable where we are in the community, and I'm pretty sure he picked up a tidy $500 USD for writing this guide. Yeah, very, very cool. And then Dev, who we've seen featured on the stream a bunch, made a new solid primitive, which is very cool, called Solid Events. I haven't looked at it yet. Maybe we'll have Dev on the stream to talk about it. But the idea is that events are different than signals, so we need events. So create event, on event, emit event. Emit event sends it, and I'm guessing, let's see here, on message, on increment. I see. So people like really like it's got like RX vibes to it, but the idea is you basically set up an event emitter, but I'm gathering on the other side on increment, mid event on increment. Interesting. On message. Does this just keep on chaining? Okay, it keeps on chaining, so it's composable. Okay, so each of these helpers actually returns, yeah, okay. Okay, so halt. Nice, okay. Async, like it. Okay. Okay, so this is how we get our signal at the end. So we consume it. We go here, give it a default value, wire in our event, and then wire our cleanup. I'm gathering, what are the 3 arguments? Or is this just a chaining syntax so you can just like put them on top of each other? Like this is like pipe, essentially, like a stream where you just like this goes into this, which goes into this. It's RX behind the scenes, yeah. Funny, I had a SolidRx library way back, but implemented a bunch of operators. But I like this. This is much cleaner. There's no point using signals like using like our reactive signals all the way along. You really only need them at the ends. Create async subject, makes sense. Create subject store. More interesting. Okay. Kind of like create projection. Okay. This is this is much more powerful than what I made. This is well deserved at the prize. I think for a certain type of pattern that I usually don't associate myself with too much, I think this is incredibly powerful. It's interesting. I wonder if this becomes more go-to. Like there's stuff like XState, which people try and feed into Solid, but this feels like it's more natural because it's that next level out. Like I've never said that signals in XState, like I think stuff like that fits together quite nicely. But there's something that's kind of like out there in the scope in terms of like orchestrating. I feel like this is a very natural fit with what we're doing. So using the optimistic API. Okay. Interesting thing about this though is this does make it more directional again, I guess, which makes it back into like put this into diffing territory. I'd have to look at this more. I'm just looking at the filter versus the direct mutation update, but it's interesting. Since it doesn't require iterating over the submissions, right? It's mapping over it. Okay. Okay. Yeah. Yeah. I'm hoping Solid 2.0 addresses a lot of these. Huh. So yeah, this is the projection, but it's like a chained version of the projection. That's where I was getting at, yeah. Yeah. I think create projection actually solves a lot of this, but not completely. So I mean, props on this being a different way to arrange it. Yeah, this is really cool. And it's what you're using with server signals. Okay. Yeah. We're going to have you come on the stream and talk about this stuff soon. Very, very cool, Dev. Yeah. Definitely. Yeah, you need timestamps for the mutations. For the board, I mean, technically there's the has updated. But yeah, this is like what you were talking about the other day when you were saying that, like, what if you just had separate functions? And I said it's their inclusion. I don't think it's odd to think of it from a signals modeling perspective because of what can rerun based on tracking, but it's not odd to think of it from an event standpoint where it's always going to go through the fixed chain. So yeah, that's very, very cool. I think that's the right place for stuff to sit. Like if you start with create projection and it's fine, and then you're like, nah, I can model this easier with some kind of like event transformation. It's like that's when you're supposed to pick up RX. That's when you're supposed to like use the proper tool. It starts basic with signals, and then you go like, okay, I want retry logic. I want other stuff. So yeah, I think it fits very nicely. Okay, so yeah, SolidHack. Again, just blasting on the stream. I'm sure you guys are all aware of this. There's lots of chances to win. Lots of prizes. Those two are claimed, but we have more unclaimed challenges. And yeah, there might be, I don't know if we're going to drop one more set of challenges before the end of the hackathon. I believe there's still 26 days left. So we definitely do keep on checking back. All right. Optimistic UI, I could do it really quick. I think we already showed this on stream a moment ago. The idea of optimistic UI is that while the server, it's basically the client gets ahead of the server. In this example here, the server, I can slow down. Yeah, I'm on 3G. I can move this card and then move this card again before the server has actually finished saving it. The idea is that essentially we're being optimistic that the save will happen. If it fails, then stuff will update as so and will show errors and stuff. But the idea is you're hoping that, you know, for simple things like clicking a like button, that it will succeed, and hoping so it succeeds. You don't block the user from continuing their activity. You just assume that it succeeded. So that's being optimistic, assuming that server won't fail. Yeah, I mean, I'm not gonna be picky. People can use web components, right? If you have a web component framework for Solid and it looks pretty sweet, I'm not a judge on this, so like very well could go to the top. Yeah, the idea, yeah, we call it optimistic though because we're hoping that things succeed. Yeah, a mitigation for eventual consistency. Yeah. Yeah, get in on it. Devs just WebSocket endpoints added docs for how to use WebSockets in Solid start. Also very cool. There's been a lot of really cool Solid stuff recently. People showing that they can use V0 with Vercel because the similarity for the like static output of stuff between React and Solid is so similar. You literally can make a couple changes to the code, and apparently people have been doing that. So very, very cool. That's Solid. For myself, I don't think I actually had very much going on. I was too busy writing all those articles that we talked about. So as I told you, this one will be fast. Yeah, I honestly, unless there's something specific that I was going to talk about, yeah, the shad CN for Solid is cool. Yeah, we have that. I have some Solid stuff. That's cool. I have some Solid stuff too. I don't know, I should retweet this from the main account, but the US presidential election and Senate election it runs on a platform called Vote Compass that's actually built with SolidJS. So everyone who's going out to vote for the US presidential election will be using software built with Solid. So very, very cool to see used in such a widely used platform. Give Vote Compass a try. Pretty cool. Mine's not working. Yeah, I mean, the biggest challenge, I think you're kind of nailing one of the bigger challenges about this is stuff like Elixir has actually nailed down, what kind of environment this needs to run on. So like, even if we figure out a mechanism that is completely optimal for the handoff between client and server, there like, is Node the platform to run it? Right. I mean, this is the classic problem. Is I think the best way to actually solve these problems involves a single language model, which makes JavaScript almost like a shoe-in. You have to use JavaScript, but we just need better server stuff in JavaScript, or we need to get other stuff in the browser as optimal as JavaScript. I'm fine with either or. The only challenge there, obviously, is that WASM is not the answer. Like we need it to be native like JavaScript, which means I'm sorry for all those other server languages. Like it's hard because like beams, yeah. This is an acronym for something to do with that platform, right? What's beam stand for again? Like what's the acronym? It's like it's the underlying virtual machine. Erlang. Yes. Yeah. Yeah, it's Erlang's VM, which is incredible. Built for this, built for telecommunications, can power. It's an incredible piece of software. So just going, oh, we should make that in JavaScript is not realistic. On the other hand, solving these problems efficiently in our area isn't really possible without anything but JavaScript. So like there's this really painful conflict here where to get the best experience from server handoff through client has to be JavaScript on both sides. But to get the best backend for doing highly concurrent work is not JavaScript. So what do you do? These seem like immovable walls. Okay, so it's not just okay. So Erlang has multiple VMs. Okay, good to know. This is the thing I've heard referenced many times. So we put JavaScript on Beam. That I mean, there we go. Okay. I mean, people are or at least writing it in like the underlying VM, like some kind of WASI or whatever, WASM, whatever thing. Like there's incentive here because of the serverless platforms and for better runtimes. So I can see incentives to solving this problem. It seems like where we're at, it's way more likely that JavaScript gets good on the back end in some way before we're able to get these other languages into the browser. It's just, yeah, it's just kind of the reality of things. I know that scares and upsets people to great end, but like these are equally difficult problems to solve. Jam socket? Couldn't come up with a I was like, it's got to be a reference to like Jamstack. Okay. Very cool. All right. Well, it was a short one. So there. I think I'm done. So until I guess next week, I'm probably yeah, let's see, 25th. Yeah. Next comp's on the 24th. Yeah, so I'm probably I can do the stream next week, I think. But yeah, Dev, we should talk, see when you can come on the stream. I'd love to pick your brain. I know you're still working on stuff, but I think you have some really interesting stuff to share. Other than that, everyone else, have a great weekend. Until next time.